I bring out two magazines. One is on steel industry, one is on mining industry. And both by virtue of being a journalist on the steel industry, I had enough opportunities of interviewing them, interacting with them. When I said starting with Mr. J. Mehra, when Mr. J. Mehra was CMD, Santosh Monde was steel minister, and Mr. Musa Raza was steel secretary. So all three of them, I personally interviewed all of them to ascertain what lies ahead for Vizag Steel Plant those days. Then when we talk about when I said Dr. B.N. Singh went through a time when RINL was almost on the verge of being referred to BIFR. So from that, Dr. B.N. Singh turned that plant around. And at Hilltop Guest House, Dr. B.N. Singh and myself, we were sitting at the footsteps of Hilltop Guest House, and I saw him calling the workers who are known as khalasis in your plant. So he called one khalasi and he said, no one will lose their job in this plant. So he ensured that no one lost their job in Vizag Steel Plant. And then later under Mr. B.K. Panda Sahab was again a person who was very close to me, so who is no more in this world. But under Mr. Panda, we had the turnaround celebration. I think you might remember, we had the turnaround where Vizag Steel Plant became a zero-date company. It was, I think, in 2005, if I'm not mistaken. Yes. It was a zero-date company. So it has Vizag Steel Plant, except for the fact that it has no captive mines in its fold, it is a gold mine. In spite of having a checkered history, it has turned its order around, and I believe this plant can do wonders. So with a great pride in my heart, I believe RINL will once again be the flagship steel plant in this country.
Sure. Whatever you have told is definitely, we also believe in that. And all the great leaders you have talked of, Dr. B.N. Singh, he was a fantastic, he was beyond anybody's doubt that, in fact, that BIFR scenario, we are also associated because I am also there from the year 1985 onwards, when the plant was just under construction, just started, and no unit was commissioned. We started commissioning from 1990 onwards, 89 and 90 onwards. So I have also seen the ups and downs in this organization, being an integral part in this. So we still have our own belief and faith in our organization structures.
Exactly. It has a wonderful, the team RINL is something which, Mr. Sagar Rao, who became CMD later, he used to always say, I'm proud of team RINL, and these leaders which you had in RINL, they did wonderful jobs, wonderful. If everything would have been gone round by now, the expansion would have been completed and it would have gone beyond 7 million tons. Perhaps it would have been a 10 million ton plant today if everything would have gone as per plan. So I'm still proud of the legacy of RINL. So with that, I think, Ankit, it's time. Let's get started.
Yeah.
So, gentlemen, Mr. Gadre, Mohanty Saab, Mr. Ajay Kumar, Mr. Biswas, Mr. Murthy, with your kind permission, let me take your kind permission to start the program because we are already beyond 4 o'clock. So, Ankit, let me introduce my son, Ankit Mukherjee, who is located far away from me, but we are tied together in today's I would say the wireless world and the wired world together. So my son Ankit will be the host for the show today. He is now located in a city called Magdeburg in Germany, which is very close to the city of Berlin, about an hour from Berlin. So Ankit, my son, will be hosting the show. Over to you, Ankit.
Yeah. So good afternoon, everyone. A warm welcome to all the panelists and attendees who have joined us today, and to everyone watching on our live stream on YouTube. We would like to welcome you all to our 36th webinar titled Steel Mill Maintenance and Lubrication, organized by Steel and Metallurgy. A warm welcome to our gold sponsor, Schaeffler, our silver sponsor, Indian Oil, and our knowledge partners, NLGI India chapter. Thank you all for making this event possible. I would now share my screen and introduce our panelists for today. First, we have our keynote speaker, Mr. V.R. Sharma, who is the Managing Director of Jindal Steel and Power Limited. We have Mr. B.K. Mohanty, Chief General Manager, Maintenance and Iron, RINL, Visakhapatnam Steel Plant. Mr. M.M. Gadre, Chief General Manager, IC Rail and Structure Mill, Roll Turning Shop, Roll Passing Design, Bureau and Plate Mill, Steel Authority of India Limited, Bhilai Steel Plant. Mr. Ajay Kumar Harinarayan, who is the Chief General Manager, Lube Technology Industrial in Indian Oil Corporation Limited, R&D Center. Mr. S.K. Biswas, DGM Technical Services, HO Indian Oil Corporation Limited. Mr. Harsha Kadam, CEO and Managing Director, Schaeffler India, President, Industrial Business India. Mr. V.S.N. Murthy, Senior Vice President, Maintenance of Steel, JSW Steel Limited, Vijayanagar Works. Mr. G.R.P. Singh, Head of Quality Assurance Group and One Shed Services Technology Group, Tata Steel. Mr. Umesh Chandra Dwivedi, General Manager, Global Technology, Gulf Oil Lubricants India Limited. So these are our panelists for today. Thank you all for joining us. Before we proceed, there are just a few short guidelines I would like to share for platform management. For all the numerous attendees who have joined us on Zoom to listen to our discussion, we have a Q&A section, which can be accessed by panelists as well as attendees. So I would request all of you to post your questions and queries in the Q&A section, which then the panelists can choose to either answer live or directly in the chat. I would also request all the panelists to keep their microphones muted when the other panelists are speaking to avoid any kind of noise feedback. And last but not the least, I would request all the panelists to adhere to the time limit as given in the program to avoid delays. Today's webinar will be moderated by my father, Mr. Nirmalya Mukherjee, who is the editor, Steel and Metallurgy. On behalf of Steel and Metallurgy, our sponsors, our partner, and of course the entire team, I would like to welcome you all to this webinar. Now we will have the national anthem, followed by which we will display a corporate video by one of our sponsors. So I would request you all to please rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे।
Now we will play the first corporate video for today, a short film by Indian Oil. Is my screen visible yet?
Not yet.
Not yet, okay. Just give me 1 second. Now it is visible, yeah?
Yes.
India's flagship national oil company and top-ranked Indian corporate in the global Fortune 500 listing. With business interests spanning the entire hydrocarbon value chain, Indian Oil is the energy of India and a globally admired petroleum major. As India's downstream leader, Indian Oil meets half of India's petroleum needs. Indian Oil owns and operates 11 out of India's 23 refineries, and a vast network of about 12,000 kilometers of crude and product pipelines. With over 45,000 customer touchpoints spread across the country, Indian Oil is the most trusted and valuable petroleum super brand of India. While Servo from Indian Oil is the leader in the overall lubricants industry, including the automotive segment, in the industrial segment, Servo has been the undisputed leader over the past several decades. With its comprehensive range of industrial grades and extensive nationwide supply network of industrial stockists, Servo literally runs the wheels of Indian industry. Backed by one of Asia's finest R&D facilities with cutting-edge lubrication technology, Servo has customized formulations to match up to the rigorous performance standards of OEMs for industrial grades of lubricants. Servo adds enormous value to its industrial lube customers through professional guidance on lubrication through its army of technical services engineers who work hand-in-hand with the industrial shop floor engineers, maximizing the advantages of Servo industrial lubricants. Servo counts among its major customers leading industries across the country, including vehicle manufacturers, steel plants, heavy engineering industries, thermal and hydel power plants, mining giants, state transport corporations, cement majors, shipping and dredging companies, besides defense forces and railways. The vast range of Servo grades meets every possible industrial application. Cutting fluids are coolants and lubricants designed to cool, lubricate and cushion the surfaces during metal cutting processes. Servo offers a range of environment-friendly world-class cutting oils to keep the workpiece at a stable temperature, maximize the life of the cutting tool by lubricating the working edge, remove swarf from the point of machining and preventing rust, ensure safety for the people handling it from toxicity, bacteria and fungi. Servo offers neat cutting fluids, which include Servo Cut, Servo Met, Servo High Cut, Servo Hone, Servo Spark and Servo Grind ranges for reduction of friction during broaching, honing, gear cutting, gun drilling, etc. Servo water-soluble cutting fluids include Servo Cut, Servo Synth Cut and Servo Synth ranges. Lubrication is an important factor during metal drawing, and Servo has a range of forming and drawing oils including Servo Form and Servo Wire Draw that effectively help control the forces and metal flow. Besides extending the life of the mold, they also reduce temperature and improve surface finish. Without proper lubrication and cooling, all the moving and in-contact rolls and materials get abnormally hot and irreversibly damaged. Servo's comprehensive range of hot and cold rolling oils for aluminium, copper and steel with varying kinematic viscosities and flash points include Servo Arol, Servo Cubrol and Servo Sterol rolling oils. Quenching of steel involves the rapid cooling, which is generally achieved by cooling at the critical cooling rate to avoid formation of soft constituents in the steel. Servo has an extensive range of cold and hot quenching oils, slow and fast quenching oils, and polymer quenchants available in low, medium, and high viscosities. Servo quenching oils include Servo Quench, Servo Martemp, and Servo Polyquench ranges. Rusting turns strong metal into flaky powder, slowly eating away at even the largest chunks of iron, costing the steel industry several billions of dollars every year. Servo has a wide range of rust preventives, including intermediary storage protection oils to long-duration protection oils. Servo rust preventives include oil-based, solvent-based, bituminous and non-bituminous grades. Rust preventives for electrostatic spray are approved by international OEMs, including B-Body and Ravarini. Servo offers a complete and one-stop lubrication solution for every possible industrial lubrication application, backed by valuable technical support. Besides being the undisputed #1 industrial lubricant brand in the country, Servo is also the most trusted lubricant brand by the Indian industry.
So that was a corporate video by Indian Oil. And I would once again like to thank our sponsors, Schaeffler and Indian Oil, and our supporting organization, NLGI India chapter, who is also our knowledge partner. Thank you all of us for making this event possible. And in the meantime, I see that our keynote speaker, Mr. V.R. Sharma, has also joined. So I would like to hand over to our moderator, Mr. Nimalia Mukherjee, to take the session forward.
Thank you, Ankit. Sharma Saab, namaskar, and a warm welcome to you. I know you have just finished with the CII meeting,
thank
and
you.
back-to-back meetings, I think, is very tiring. But in spite of that, Sharma Saab, the fact that you could
Thank you very
keep the
much.
time,
Thank you.
really grateful to you. And as I keep saying, whenever Mr. V.R. Sharma talks on a topic, it is the Indian steel industry talking. So he is the spokesman for the industry. And whenever I read comments after every webinar or on social media, one syllable which is used to define Mr. Vidyaratan Sharma is encyclopedia. So he is known as the encyclopedia of Indian industry. So, for the last time we did one on digitalization in industry 4.0. So I had, doubts whether for a topic like digitization, should the CEO be talking on a subject? Should the managing director of a plant be talking on a subject like digitization, which are handled at a much lower level? But then I realized I'm requesting, the captain of Indian industry, captain of Indian steel industry, and someone who has placed Indian steel on a global platform, Mr. V.R. Sharma. So it's not, praising him. It's explaining the reality for people who are less aware of what is happening in Indian steel today. So the Indian steel industry has been placed on a pedestal thanks to our captain, Mr. V.R. Sharma. So with that, and a warm welcome to Mr. V.R. Sharma. Before he speaks, just a few words on why we chose this topic, steel mill maintenance and lubrication. Now, as you know, the steel industry is on a massive ramp-up stage. We are ramping up our capacities. We need to reach the 300 million ton mark by 2030 at our NSP 2017. And when your demand goes up substantially over a short period of time, and over and above this, the Chinese crisis has added, I would say, benefit to our industry in terms of giving us leverage. So in these situations, what happened is you put your steel mills to the limit. You go beyond your rated capacity. You run your plants beyond its nameplate capacity. As such, you're pushing your mill to the edge where maintenance becomes so very important. And you know how much expenses are steel industry is a very capital intensive industry where we spend a huge amount of money on our spares and maintenance. One bearing goes, one large size bearing goes, you lose lakhs of rupees. So similarly, when we don't maintain your rolls in your roll shop, when you don't maintain your spares, your electrical spares, your other spares, and where lubrication plays an important role, because my father was a lubrication tribologist himself. So I have seen what tribology is from a very small age. From my days in school, my father used to, instead of using a kettle, he used to use, small, I would say, container at home to make grease at home. And so that is how I knew. And when my father bought me a bicycle, the first thing he told me was maintain it well. So maintenance of that bicycle was only by virtue of the lubrication, which I had started practicing at a very small age. So with that, and a warm welcome again to Mr. V.R. Sharma. I would request Mr. V.R. Sharma to address us as the keynote speaker today.
Thank you, Namilaji. Thank you so much for giving the very nice introduction. Thank you, my friends, those who are listening me today and those who are participating in this webinar. Each time when I come across with Mr. Nirmala and the steel and metallurgy, they come out with very, very practical webinars which are useful for engineers, technicians, entrepreneurs, and also the suppliers and the customers. The topic says today the lubrication and maintenance is a very vital part in our steel industry, and for that matter, any engineering industry. Because the metal to metal rubbing or metal to sandwich metal or bimetal rubbing is a very tedious exercise, and we lose a lot. You know, in good old days time, even the the bucket when we were taking out from the well, the water bucket, and when it is the rope is going time and again from the top of well through a stone or through bricks. It used to cut the bricks or stone, the rope. So you can imagine if there is a metal to metal contact, so what kind of friction we'll be achieving, and unless a right amount and right quality of lubricant is not used, then the steel production is not possible in today's time. So the lubricants basically worldwide, they do not cost too much when we see the cost of equipment and cost of benefits, or we take out the trade-off. So normally steel industry is consuming lubricants from in international currency like 50 cents to $1.5 per ton of lubricants in any of the steel industry for different applications. So for example, if it is lubricants for the cold rolling mill, then on average we consume about 0.3 kg, say, or maybe 300 grams or 400 grams of lubricant per ton of steel, cold rolled steel. If it is something like hot strip mill, we go for a lubrication in stand 1, stand 2, and there the cost comes about say 70 to 80 cents. And finally, if we see the average cost in industry, that does not go beyond $1.5 or say 100 rupees or 110 rupees per ton. So it is a very small part, but very, very essential. I also know that the oil industries, they are struggling, they are working day in, day night as to how to enhance the life of the equipment, be it hydraulic oil, be it lubricant oil, be it high temperature oil, high temperature greases, normal EP2 greases or general purpose greases, whether these are lithium based or graphite based. There is a product available for any kind of requirement. And nowadays, most of the hot strip mills worldwide, they are using more oil bearings, and where the oil again plays a very vital role because these are the bevel bearings. So there has to be a particular film which is to be maintained in terms of 10 to 15 microns or sometimes 20 microns, depending upon the viscosity of the oil. And if that fails, then it creates havoc. Everything goes standstill. The bevel bearings, they get melted, and the complete mill comes under breakdown. So it plays a very, very vital role. Similarly, when it is a closed bearing, sealed bearings like Timken Tiparola bearings or NSK bearings or SKF bearings, FAG bearings. So all these bearings, they have sealed bearings as well as the open bearings. So normally when rolling mills, people prefer to have the sealed bearings. Otherwise, the coolant will carry away the bearings from the bearing cage, and finally there can be. So we all know that what kind of oil, grease, lubricants are recommended by various suppliers, and how the lubricants are working in that direction. So I was seeing the presentation from Servo. I visited their Faridabad Research and Development Center many times in 1990 to 2002, and we discussed many of the products because they had initially a collaboration with Mobile, and then finally they developed a lot many rolling oils, servo rolling oil, RP oil, that is rust-preventive oil, and also rolling oil for the cold oils. It is a emulsion oil. Basically, you put into water with 2 to 3% of concentration, and then rest of the things are done by the oil. Similarly, we had worked with Horden, we had worked with Ushiro of Japan, we have worked with Quaker Chemicals, we have worked with Stuart, we worked with many other companies, those who are in this business of supplying rolling oils. So ultimately, we found it is a very, very important part. But of course, sometimes we negotiate too much with the oil suppliers, I think we have to have a very balanced view to make our life better and to make our equipment healthier. We should try to use the best oil available in the world for a particular application. So high temperature greases, like in blast furnaces, in hot applications, in the reheating furnaces, we are using for the sport rollers or the hot rollers. We are using high temperature greases which can sustain even at 2000 degrees centigrade temperature. Not directly, but yes, of course, indirectly. The body temperature is maybe 600 to 700 degree only. These are extremely good high temperature greases available nowadays. Similarly, as I was saying in the advertisement, at the heat treatment cooling oils, 900 degree, 950 degree, the right amount of temperature, right amount of viscosity, and the right amount of oil quantity, and a cooling system across all the four sides of the immersion pot, so that there is no fire and we achieve the properties as required. And then finally, nowadays, the indirect heating is such a wonderful behavior and wonderful phenomena that we can maintain the temperature for tempering also, and that can be around 300 to 400 degree, and that is again indirect. And finally, we achieve the metallurgists, they achieve their goal, their mission, that what the product will be, what is the hardness, what is the grain structure, and how we can achieve the right properties, and how can we avoid the metal to metal rubbing or metal to metal friction. So this is a very wonderful development. World is moving in different directions. We have seen the hydraulic oil, which plays a very vital role in the hydraulic system in the aircraft. And we have seen the hydraulic oil, which is being used by the hot strip mills, where even a drop of oil can create a havoc. Now the new developments which in the field of lubricants and oils are going to take place, because now everything is based on the base oil, fossil fuel, and some of the organic compounds. So now the time has come, especially for India, to convert coal into lubricants. So this is a very new subject. How to convert coal into lubricants when we can produce coal to hydrogen, coal to methane, coal to plastics, coal to ethanol, coal to methanol, and then why can't we produce coal to greases or coal to lubricants? So I think for a country like India, who wants to become self-reliant in many of the technologies, the new technology which is likely to come in future, which is going to knock our doors, that will be the technology for converting coal to lubricants. We have seen many of the windmills in the world, they catch fire at 120 meters height or 200 meters height. And we find that the complete mill is burnt, and finally, it damages the environment also. So all these windmills, they catch fire because in most of the cases, as per the studies available, the right quality of oil or lubricants were not used by the gearbox suppliers or by the service engineers. So we have to see that, yes, all these things are in place. So technology is changing, world is changing, and so are the lubricants. So it's a very vast subject, though I'm not specialist of this subject, but as a user, I tell you, whether you use lubricants or greases from, or the rolling oils from Indian Oil or from Bharat Petroleum or from Caltex or from any other company or from Quaker Chemicals, Stuart, now Horden is also, I think, it is merged with Quaker Chemicals, or the other way around, or the Fuchs Chemicals or the Total, I mean, whatever the name of the companies may be. It is not necessary that each and every company can make a similar product. Yes, there will be plus and minuses, but yes, at least one company makes one good product. So we must believe that one brand is good for a particular usage or particular application. So it is up to operators and the maintenance engineers that which brand is stable for them, which product is stable for them, and what should they do. Like the requirement nowadays are much more in terms of risk preventive oils for the steel, especially for the forged items, machined items, screws, cold rolled material, and many more components. So there we need to have the rust preventive oil in a particular coating. I mean, the thickness should not be more. Otherwise, the oil droplets will spoil the total packaging, and it's very difficult to clean when it is going to be fixed in a machine or in a car or motorcycle. So these have to be very, very special oils where the ultra thin film of 2-3 microns can protect the component for months together. So these are the challenges what people are facing. And then, we have to see that how to reduce the overall CO2 footprint. More oil means more CO2 in any case, either through the production route or through the usage route. So we have to find out how to reduce the CO2 emission and how to bring down the CO2 footprint. Of course, in a total of 2.4 or 2.5 ton of CO2 per ton of making steel, the effect of lubricants is very minimal. It is less than 0.1 ton of the total CO2 generation. So, but still, if you can reduce it to 0.05, it is better. And this is the demand of the day. The country is going to produce 300 million ton steel by 2030, 9 years to left, and 9 years to go. So in this 9 years, I think great amount of opportunities will come for the lubricant manufacturers, oil manufacturers, grease manufacturers, the bearing manufacturers, the beveled bearing manufacturers, the white metal beveled bearing manufacturers, and the high temperature grease manufacturers. A lot many opportunities will come, and a lot many application engineers will be required. So that means more and more employment generation will take place in times to come. So today we feel that this is a very low cost item, and maybe 100 rupees a ton of steel or 150 rupees a ton of steel, and for some applications just 20 or 30 rupees per ton of steel, but it is very vital. So we have to see that it is an aspirin which can save the life, though the aspirin costs how much? It is a peanut. So we should treat that the cost is less, too less, but the advantages are many. And this is what my experience is. I never tried to compromise on lubricants in my life, and that has helped us in terms of reducing downtime, in terms of improving OEE, and in terms of maintaining all 8 pillars of TPM. And the first and foremost thing is, of course, cleaning, and then the lubrication. So thank you once again, my friends. Thank you. All the best to all of you. And I'm sure you'll be enjoying the session, which is continued. Thank you.
Thank you so much, Sarma Saab. And whenever you hear the encyclopedia, you get to learn something. So today, for the first time, I came to know about coal to lubricants. So that's what's a learning experience. Earlier, it was Mr. Sharma when we did our webinar on hydrogen in steel making. He pointed towards the usage or production of hydrogen by using coal. So a new direction is always provided by the encyclopedia whenever you hear him. Now I remember when my father used to talk about graphite, use of graphite in lubricants. So carbon is an essential element which you need. And the best form of carbon, as we know, is coal. So obviously coal has a major role to play in the national economy. That is why we decided that we'll have an entire session on using the coal responsibly. And Mr. Sharma has always been saying that coal is not a bad element, or it is not blasphemous to use coal. Judicious use of coal is what our country needs. And India, by being blessed with so much, even today, if you look at Germany, they're facing a tremendous amount of challenge when this theme comes floating around that you have to stop using coal altogether, no fossil fuels. and that brings a tremendous amount of challenge to the Western world. And we, as Indians, we should be proud that we have so much of resources available which we can use. And it is really fortunate for us to have Mr. V.R. Sharma and his thoughts to keep the philosophy going that the resources in this country should not be wasted. It should be used judiciously. It should be used in a proper manner. Usage of coal does not always mean you are adding your carbon footprint. There are so many ways, just as you cannot say using steel is a challenge because steel corrodes. There are so many things you can do to stop corrosion of steel. In the similar manner, there are so many ways you can adopt to stop reducing your carbon footprint, even by using coal as a resource in this country. So with that, thank you, Sharma Sahab, once again, for always showing us the path forward, for being the so-called Mark Darshak. You are the real Mark Darshak of our industry and showing a new path forward, which helps us in a sustenance. And it's a very practical approach. Today, if you suddenly start saying that we will stop using coal in our power plants, we will be living in darkness altogether. You cannot think of having nuclear power plants overnight. Even then, if you have it, there are so many challenges there itself. So obviously, whatever solution you have predicted is the most practical solution that India can think of as of today. So thank you, Sharma Sahab, once again. And may I now request Mr. A.K. Saxena, Director Operations of Vizag Steel Plant, who was supposed to be in a meeting, but in spite of that, he has been able to join. Saxena Sahab, आप सुन पा रहे हैं? नमस्कार सक्सेना जी. Saxena ji, namaskar. Ankit, can you see if Mr. Saxena is connected?
Yeah, he's in the panel, but
Saxena ji, namaskar. Can you hear or is he? Anyway, we'll come back to Mr. Saxena. He's there on the panel, right?
yes.
Saxena ji, अगर आप सुन पा रहे हैं, okay, maybe he is not there.
Mukherjee sir, Saxena sir, our Director Operations, he is busy with another meeting of EGC for that coals. So he had asked me to be with you here on this. So he may join anytime once that meeting is over.
Okay. Oh, we'll come back to Saxena ji once the meeting is over. Okay, so we'll now thank you, Sharma Sahab, for your inspiring words today. And we all feel that you show us the right path forward. So we will now move on to our next speaker, Mr. B.K. Mohanty, who's again from RANL, Vizag Steel Plant. And as I keep saying, Vizag Steel Plant is a plant very close to my heart. And, I have seen the plant since early 90s when Mr. J. Mehra was the chairman, right through to Dr. B.N. Singh, then Mr. B.K. Panda, Mr. Madhusudan, Mr. Sagar Rao, all the CMDs since then, since early 90s, so almost 25 years, more than 25 years, I would say, I've been watching this plant, and it's a wonder for all of us. And as I always keep saying, the plant must go into good hands. And whenever I speak to Mr. Atul Bhatt, the present chairman, I keep telling him, you are going to do exceptionally well in this plant. Under the present circumstances, this plant will come back and get back its glorious days. During Mr. Panda's time, I remember we had a grand celebration in Vizag with the turnaround celebration, where all of us were taken to Vizag. We had a gala of a time for 3-4 days with the overall celebration with the turnaround, where Vizag Steel Plant became a zero-debt company. And that is what Mr. Sharma is going to show at JSPL also. Very soon you'll see JSPL as a zero-debt company. This year itself, he has already mentioned that it will be less than 10,000 crore debt, and very soon you'll see JSPL as a zero-debt company. So it is leaders like them, Dr. B.N. Singh. I remember Dr. B.N., as I was telling you, Dr. B.N. Singh and myself, when we were sitting at the step of Hilltop Guest House in Vizag, on the top of the hill, Dr. B.N. Singh clearly said no one will lose a job in this plant. And thereafter we saw the turnaround. So the steel industry has a resilience of its own. This is what makes me so proud of being a part of this industry. It is such a resilient industry. Whenever there have been challenges, we have come up. And as Mr. Sajan Jindal keeps saying, every opportunity, every challenge brings opportunities. So whenever Vizag Steel has faced a challenge, they have come up with solutions and turned the plant around. Now we just pray that during this, what we call disinvestment of our RNL, the RNL should go into good hands.
Okay.
Good, and once it goes into good hands, this gold mine, RINL, will build another steel plant of similar size, if not more. So I think when JSPL talks of having a 25 million ton steel plant at a single location, Vizag steel plant has so much of land, so much of land freely available. You can build another 2 steel plants at the same location. So with that, Mr. Mohanty, I would like to hear from you what Vizag Steel has up in sleeves and how Vizag Steel plant is looking at steel mill maintenance and lubrication, which is so very important element in a plant maintenance. Over to you, Mr. B.K. Mohanty, Chief General Manager, Maintenance at RINL.
Good afternoon, all. Sharma Saab, Mukherjee Saab, and Mr. Garre, and others. My Director of Operation is not here. I think he'll join soon. Mr. Ankit, I had shared one presentation in terms of a PowerPoint presentation. Can you show that here?
Ankit, do you have the presentation?
Yes, I'm just opening it.
I just made a small presentation to showcase that what Vizag Steel has done in all over these 30 years plus, especially in the steel mills and steel mills area. We have, you know, that we have got three mills in our 3 million ton scale, to which we added another 3 mills. Total, we have right now 6 mills. All of them, they produce long products, and the products what ranges is from rounds 5.5 mm in our wire rod mill to the sizes of like billet of 90 size, and we have also started producing billets through rolling to the extent of 125 square billets. So yeah, this is what.
Yeah, Ankit, can you start sharing your screen?
Yeah, can you see?
No,
Yeah,
I
yeah.
can't. Have you started sharing the screen?
Yes, my screen is not visible.
Okay, maybe I have some issues. Anyway, go ahead, yeah.
Yeah.
So it's about rolling mills maintenance and lubrication. To start with, can you go to the next one, Ankit?
Yes.
These are our present status as far as that 7.3 million ton of steel production plan is concerned. We have got right now 6 mills. The last one is not coming up here. We have this light and medium merchant mill, which produces billets of 125 square, and it also produces rounds and revers up to 36 mm rounds as well as revers we have been producing. This is then these billets of 125 square, which goes into our wire rod mill 1, and there we produce from 5.5 mm to, in fact, we produce 12 mm as a general product. Sometimes we produce also 14 mm planes. This we have both the varieties. We have planes as well as revers. Then we have this medium merchant and structural mill, where these rounds, angles, channels, beam squares, etc. also are produced. Then we have these 3 new mills coming up. It came up during our expansion, and that is wire rod mill 2. It has got a special rounds of 5.5 to 20 mm sizes under its production portfolio. Then we have this special bar mill where the sizes are from 20 mm to 45 mm, both in straight and coil form. Then one more is not visible, that is our structural mill, that is STM, we call it STM. Those are also again the structures with higher sizes of rounds and other structurals. Next screen, please. Yeah, this is what is the layout, and then we have these capacities mentioned here in each mill. which goes for rolling in both billet mill and wire mill, as well as the billets which are rolled from billet mill, it goes to wire rod mill. The wire rod mill capacity in the first phase was 10,94,000. It has been enhanced from a capacity of 6 lakh tons in the initial period. And the bar products what is produced is also 8,98,000 from a original nameplate capacity of 7,10,000 tons. And similarly, Ankit, there is a problem with the screen.
Okay. What is
The right side, there is a block.
okay? Okay. 1 second. I will. Yeah, actually, there is some problem with my cursor. I am not able to get. I'll try to fix it. Just give me a moment.
Can you close the file and open once again?
Is it better now?
Yeah. Still, there is something left on the top corner. I think this can be managed, but the screen is not coming complete. Something is still missing at the bottom.
Okay. Yeah, I am not sure.
Okay, we can. I think this should do. This much will do. We'll go to the next one.
1 second. Again, my cursor is not there, so I'm not able to change the slide. Just give me 1 minute. I will try something else.
Yeah, it's fine.
Is it better now?
Yeah, it's fine.
Okay. Yes.
So go to the next one. Yeah, these are the capacities of various mills that we have. The 6 finishing mills that we have here. The capacities are mentioned at here. Like the last one, the last, which was that structural mill STM we call it, which was commissioned the last. The capacity is 7 lakh tons. And the other 2 new mills under expansion, wire rod mill 2 has a capacity of 6 lakh tons. This is actually our overall layout. I'm just showing it the mills portion here in the right side. Wire rod mill 2 and SBM, special bar mill, that is having a capacity of 7,50,000 tons. Next one, please. Now, to talk about the maintenance of the rolling mills, I have just picked up some of the equipments which are vastly located in almost all the mills in our, generally located in almost all the mills, in all our mills. So because it is all like handling long products, those are like reheating furnaces, which is definitely is there for all the rolling mills across the steel industry. That reheating furnace for different sizes of products that is heated up, different input material. Then we have the mill proper, where the rolling takes place, and then we have various types of shears, from trunk shears to emergency shears, cutting cutting the emergency, doing the emergency chopping, and then there are shears which pendulum shears are called, that to do the end pieces, that head end or tail end of the billets to be sheared once the rolling has to be started from the roughing stands. Then there are loopers, loop formers. Then we have got no twist mill and reducing and sizing mills in our wire rod mills. Then there are coilers in wire rod mills, as well as we have garret coiling in the special bar mills. Then there are cooling beds for long products, roller tables, compactors in for wire rod mills, where compacting of the coils is done. Then there are strapping machines to bind the coils, and overall there will be hydraulic and lubrication systems. There is one more, that we handle the cranes in most of the all the bays, or all the entire shop will have different cranes. Some cranes are meant for the maintenance purpose, maintenance cranes they are called, and remaining ones are called as production cranes, where the finished products are handled. Next one, please. Next, please. So I have talked of certain basic type of maintenance that normally we are supposed to carry out in rolling mills. To start with, the basic one, that is the preventive maintenance, which is a planned preventive planned activity that is performed, which covers inspection, lubrication, retightening of fasteners, and other routine maintenance activities. It is done to minimize the failures. That means there are no undue failures taking place while the rolling is in operation. That means this is to take care of most of the things, most of the maintenance requirements of any equipments. Then we have gone into the predictive maintenance category of equipment, category of maintenance, where the all the activities which are done on a predictive basis, where we try to do fix the things before it really fails. Like we decide the life cycle of a component, let's say a bearing or some input gears or some coupling or some seals. Like that, we have a periodic based, you have a different period where we do the predictive maintenance activity, and we do it really before it has failed. So next one, please. Next slide, please. Then we do the corrective maintenance, where we do the root cause analysis for any failure. Like we start facing a lot of failures during the commissioning stage. In fact, almost all equipment needs to be looked as if a newborn baby, and then you start looking at what all things can go wrong in that, and then if there are failures taking place which are repetitive in nature, to get into the root cause of those failures, and then try to find out what could be the required solutions to do that, to implement that in the material or design, or go on and replacing the equipments in a more frequency sort of things, because really it does not stand there. We have problems. We had problems in many of our equipment, such as cooling beds in our billet mill, that which rolls blooms to billets. So where the bearings were of not right choice, right design, so we had to go on replacing it in a very frequent manner, and we have to continue with that, because the other alternatives do not work. Then the fourth one type is the condition-based maintenance. So the activities are used mostly in our rolling mills equipments. Considering the superior design of equipments, we must have a continuous health checkup of the equipment, so that we don't face a failure, which costs us a lot in terms of the production as well as the loss of spares. So we must continue to do this condition-based maintenance extensively. And in the most of the modern mills now that have come up in our plant as well as in other steel units, they are equipped with online condition monitoring systems, where the data is continuously captured, and the alarms are set for finding the deteriorations, if any, in the equipments, and then it is addressed in right time so that the failures are not taken place. One, please. So this one is generally is not is a good thing, that breakdown maintenance we are forced to do sometimes. We need to attend to the failures which has happened in spite of all the periodic or condition based or preventive maintenance or lubrication. In spite of all that, there are some failures which take place, which are the things which need to be avoided to the maximum extent, or rather it should be a zero sort of thing. But in spite of that, because we have to run the equipments on 365 days on continuous basis, there has to be there are failures which are to be taken care in the correct approach. Like if we try to learn things on every breakdown situations, something or other is learned, whether to take care of the spares quality or the assembly procedures or things like that. Then one particular type of maintenance we generally use in rolling mills, where we call it opportunistic maintenance, where the maintenance time is available because of the problems which others have, because of others' problems. Let's say that there is a power supply interruption, something, the mill is down for some time, then the time is used for doing some maintenance. That is an opportunity created because of some other reasons. That is used as a opportunity maintenance. Next one, please. Next, please. So this is one tool which we have been extensively using, is this reliability centered maintenance. Go by the cause analysis of the failures. So we find out the real reason of the problem that has caused this failure. So go into the equipment, components in the equipments, and each component is analyzed about its capability to perform the required function there, and the material or the design or the suitability of that sort of component in the particular case. I'll give one case study where in one of our reheating furnaces was causing a lot of delays because of the failure of the bearings in the discharging side doors. The doors are driven by the doors are connected through pulleys. The pulleys bearings were of anti-friction bearings. We used to use high temperature grease, but in spite of that, because of the excess temperature, the bearings are failing very frequently. So on analysis, we found that that particular bearing will not be able to work. We have gone for plain spherical bearing there, and then it started giving a very good result. The failures have totally been eliminated by this design change. So this bringing out the reliability in a machine can be done by analyzing the failures of each components at component level and doing required required changes in that, and this will improve the availability of the equipments. Next one, please. Next. Then these are some of the equipments that we normally put forth to do the maintenance works in a systematic way. The divisions could be like in reheating furnaces. Let's start with the reheating furnaces, which every mill will be having. It has got gas pipelines, then valves, and then fans, and then it has got its cooling systems of the members which carry the product inside the furnace. Then there are pushers associated, discharging machines, as well as there are hydraulic systems. The rough way the furnace can be described with this. So next one. So like if we talk about what do we do with the gas piping network for the maintenance part, we mostly do the condition-based maintenance involving ultrasonic testing. Thickness is measured and pipelines are planned for replacements, etc. Similarly, combustion air, the fans which provide the combustion air, they are monitored, and the vibrations are monitored for the bearings, and it is fed into the alarm system of the furnace, and whenever the threshold is crossed, then the bearings greasing or replacements or the replacement of total fans can be thought of. Then the refractory is integral to the furnace. So refractory healthiness is very important. So condition maintenance and then finding out the best possible life with different types of refractory is the key to carry out the refractory maintenance of the furnaces. Next one, please. Similarly, the members which are there inside the furnace at high temperature, the ones which carry the products inside, that is the blooms or billets, etc. They are all temperatures of the cooling water that passes through those members are very meticulously to be monitored, and that condition based attention is to be given based on the temperature rise, undue temperature rise in the coolants. The vacuum beams which carry the material from inside the furnace, from the charging to the discharging end. The preventive maintenance is again the key there, that the rollers which are heavily loaded, the wheels which carry the entire structure of the furnace, they are heavily loaded, and then it is required to do the rotation of the bearings from time to time, so that the bearing is over period of time they are uniformly loaded. Then there are recuperators which requires periodic maintenance, like go for replacements in a capital repair time, or go for a in situ replacement of individual pipes depending upon the schedule of maintenance available. Next one. Then these are some of the operational necessities which maintenance has to support, that is the safety interlocks through the instrumentations and other controlling elements which ensure the correctness in the temperatures and pressure inside the furnace, and the volume and the flow of gases, and all those control valves which control the things will be properly calibrated, so that the furnace safety is ensured, that furnace is not overheated, product is not overheated, or it is not underheated. And finally, we have to be doing this audit of the furnaces from time to time, to ensure that efficient way of the furnace operation is ensured. And for this, we need this data acquisition system, which has to collect, which is in the process of collecting the data around the clock, and those data is analyzed, and then we can plan the maintenance of the furnace in a right way. Next one. So this is about the mills, the general equipments which are available in the mills in our area, in our plant, is that main drive motors, main gearboxes, and rolling mill stands, main drive gearboxes, as well as rolling mill stands, rotary shears, then pendulum shears, crank shears, snap shear, cold shear, cooling bed and finishing area equipment, loop formers, various roller tables, and so on. So next one. So this, yeah, one back, please. Next. Okay, the drive motors are missing actually. The motors also, these are all major drives in the mill. So the motor health checkup is also a condition based, and the pickups are there in the motor bearings to pick the vibrations, and the lubrication of these bearings and motors, and the cleanliness of the loads for the cooling, etc., is to be properly ensured. Similarly, for the main drive gearbox, we carry out condition-based maintenance and preventive maintenance. They are all provided with centralized lubrication systems, and the pressure and flow of the lubricants are monitored with proper interlocks to avoid deficiency of lubricants. And in the couplings also, similar way, the lubrications and the proper cleanliness of the coupling with periodic replacement of the grease and grease, etc., is also carried out. Next one. Okay, main drive motor is here. This is condition-based maintenance again. The routine checking of higher values and winding is also of importance. The motors are the process in the rotary process in the motor which are mounted on the shaft for the earthing of the current transmitted to the gearbox are maintained on weekly basis, because this is one of the area which we have found that it has caused a lot of failures in our bearings. The leakage current that is passing through the motor shaft is passing through the gearbox bearings, and then the bearings were failing. So this is one of the major fault that has been found in some of the drives that has been attended. Next one, please. Then these are the panels for driving the motors. There's a condition-based maintenance and thermography are in use for doing this one. The electrical panel main drive transmits the heavy electrical loads. The terminations of panels are prone to high temperature in case of looseness in terminal joints. So thermography is the tool that is used here to find out the hot spots and attend to the problems. Then there are loop formers, that is called loopers generally. Condition monitoring of loop scanners are done periodically. These loop formers malfunction directly affect the quality of the product. Then the calibration of loop scanners is also to be done periodically. Then there are shears. Shears, we replace the blades in the shears, and also the other mechanisms are maintained by manual lubrication of the couplings. The blades of the shears are replaced on time-based, that is exactly the tonnages it has rolled in a particular period of time. From shutdown to shutdown, it can be planned in such a way that extra time is not required to take the change the blades in between the campaigns. Next one, please. Then in maintenance of the backlash between the arbors is also very important. May I answer this question? Anyone can share the benchmark value or loop cost percentage? Sorry. Okay, we can attend that later. The blade gaps played a vital role in proper cutting of the material. The backlash in the arbor increased with time. The backlash is checked periodically, and after a particular value, the bearings or the bush that is in the crank, that is to be changed. Then there are instrumentation systems in the mills. All mills instruments are checked periodically for calibrations, and they are to be ensured in the healthy condition to ensure the proper monitoring of the mill parameters. Then online gauge monitors, that also we do the periodic maintenance. The cameras, motors, air filters are maintained periodically to ensure proper reading of the dimensions. Then on the cooling beds, most of the things in the cooling beds requires manual greasing, bearing few automated greasing systems. So timely lubrications as well as replacement of the worn out parts are carried out in the cooling beds. Next. So the next one is the hook conveyors generally used in the wire rod mills to handle the coils and the finishing area. The this manual greasing of track rollers, support rollers periodically carried out as per schedule. Then overhauling of the hooks is also carried out, and some these replacements comes after a year of, let's say, 8 to 10 years. We need to change the linkages. Then on the compactor and sapping machines, this is one area where the reliability is very less because the small components and the speeds involved in that. So it is all done on the tonnage and time-based preventive maintenance. That is the best way to attend to this compactor and sapping machines. Then we have these cranes in all the bays of the rolling mills. So lubrication of the wheels and couplings, and wear out replacement of the wheels after a particular level of 50% worn out of the wheel threads. The wheels are replaced. Then the normal lubrication and maintenance of the gearboxes and changing of ropes on a condition based. Those are the activities of maintenance that is carried out in the cranes. Next one. These are some of the maintenance strategies that we follow in rolling mills of VSP. That is daily inspection of the equipment, weekly inspection, weekly shutdown, then capital repair. These are the four care of maintenance we follow in the rolling mills here. Next one. These are some of the case studies where we have faced certain challenges. I like to share. We had one cooling bed, a turnover type cooling bed, which is part of the light and medium merchant mill. The rollers are subjected to very high temperature, considering being front of the cooling bed, where the billet temperature was something beyond 1100 degrees. And the grease, it was originally a grease supplied to the centralized system, was getting charred. So it was an initiative taken by our group of engineers who installed one oil air lubrication systems in those bearings, and that has completely eliminated the problem. Then there was frequent jamming of guides and looper rollers on the intermediate and finishing stands of the mills. They were supplied with the grease lubrication. There also because of the high speed, the grease was failing. So then we had this option of going in for air oil lubrication in those guides and looper rollers in the intermediate and finishing block. That also has eliminated the problem. Next. Then there is one problem which must have been faced by many old companies having old mills, where the grease was continuously gets washed off from the chokes of the mill. So the grease, whatever was being used, was EP2, that was creating a lot of problems, because water ingress used to take place and grease was getting mixed up with water and it was losing its property. So with IOC's initiative, Indian Oil's initiative, they had developed one WR2 water resistant WR2 grease in place of EP2 grease. After we have started using that in the same centralized system, this problem has been virtually eliminated. Then there was another issue of wearing out of the spline shafts of gear spindles in wire rod mill. They are lubricated with CG50 lubricant, but then we were finding that the wear out pattern was so high that it was becoming difficult to maintain. So this was next one, please. So this was replaced with a mobile 111 mobile X 111 grease. So this is given very good life of the spline shafts. Then this is some jamming of the bearings in front of the cooling beds in medium merchant and structural mill. The grease that was being used was Turboplex LC1. The rollers are not having problem earlier, but with the introduction of a new product and we started rolling a square size 90 billets, the area got temperature got overall become more, and that is how the rollers started getting jammed. Then we have replaced this with the Turboplex Super ST, another grease, excellent grease made by this Indian Oil, and with that the problem could be solved. Next one. In our expansion mill, certain challenges we have faced, and even we are continuing to face. That is to manage the spares in those areas, because we were not having many spares along with the original equipment supplies, where the limited number of limitations of our limited number of spares only were provided by OEM. Then it was becoming difficult to attend to any maintenance, because the assemblies or sub-assemblies or components were very limited in use. So we had the problem in initial phase. So what we have done is selective way of identifying those items, and then developing those through reverse engineering. We could develop the drawings and then could get some manufacturers, equivalent manufacturers, that they could come in handy, and they started supplying those replacement items. So we are having better facilities for our maintenance activities, because mostly when we go in for maintenance, the spares becomes the major issue. If the spares are available in sufficient numbers, then the maintenance durations as well as the quality of things could be attended. Then the augmentation of the spares manufacturing facility of in-house spare manufacturing facility that we had to do certain outsourcing of some of the activities. So Ankit, there is any problem?
There is some feedback, I think. I would request everyone to keep the microphones muted. Yes, please go ahead.
So next one. Next one, please.
Yeah.
Yeah. This is where we were, that in the expansion means we are.
Yeah, Mr. Mohanty, may I request you to please conclude, because we are already late by almost 40 minutes. So if you could please conclude.
Sorry, Ankit, can you repeat what?
Yes. So he asked you to conclude, because we have already exceeded the time limit.
Okay, then can we move fast to the lubrication one? Next move. This is management of lubricants in steel plants.
Previous one?
Yeah,
This one?
yeah, yeah.
Okay.
This is this is like rolling mills has got widespread lubricants requirements. Next, please go. I'll just speak. I've spoken about what has been done in our steel plants about the maintenance. This is about the lubrication. The roll neck bearings were traditionally lubricated grease. Mr. Verma also has given the insight that we have a mill. We have gone in for the Morg oil bearings with oil lubrications. Next one, please. And this ARL lubrication systems in high-speed areas. This is one of the findings in the new mill applications, and we have tried to incorporate the same in the other areas of the plant. Then this mobile Vacuolane 525 is an oil imported in nature from Mobile by Indian Oil, and that is used in our wire rod mill finishing blocks. Next. Hello. I'll call you back. So we can skip this. This is how ARL lubrication system works. Please go next. This is about the Morg oil bearing lubrication systems used in rolling mills. This is again about the replacement of the traditional grease lubricated chocks with Morg oil bearings and Morg oil system. Next. 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 This is what I was talking about, Marvel Vacuolane 525, which are used in the wire and mill intermediate block and finishing blocks. There is still continue to be an imported one. We have tried with Indian Oil about the replacement grades here. So far, we could not be successful. That is what will be our target next. 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 This is very much various means of selection of the lubrication systems, lubricants in the centralized oil lubrication systems and oil air lubrication systems. I'm sure it is other steel mills also. Please go next. Next. This is one statistical data that lube oil analysis what we get what we got in our mills. These are the TAN numbers and the viscosity grades, and we keep monitoring the oil conditions. Next. These are some of the statistics on the grease lubrication, centralized grease lubrication system. Next. Next. This is again how to select the grease for different application. Roller tables in the front of the furnace, like Mr. Verma was telling, we have also grease imported from Germany, from Fuchs, where the temperature ranges are more than 200 degrees. And there we have gone in for this calcium sulfonate polyurea based synthetic grease are selected in rolling mills with grease lubrication chocks, lithium calcium based water yeast and grease are selected. Next. Anyway, thank you. It has become quite elaborate. We generally, because we have got 6 mills, it tried to collect different aspects of maintenance from all different mills. So it has become a little bit lengthy. Nevertheless, there are some queries I would like to answer. This is what is the speed of wire rod mill for rods. In the old mill, we had up to 80 meters per second, and in the present new mill, we have gone up to 120 meters per second. Yeah, it is up to 1 meter. This RCM we have actually, the RCM we have tried to implement in the major areas of failures where the failures used to be repetitive and costly. So it is not in terms of number of assets. It is like a case-to-case basis, because anything we try to change in the original design, it takes a bit of time, and then it involves a lot of brainstorming and study. So probably we could have done about 10% of the problems we have so far could have done through this RCM techniques. This our maintenance cost for if we talk about only the material cost, it will be like different. But if we talk about the total maintenance cost, our cost of per ton of steel, it is about 226 kgs per ton, 0.26 kgs per ton, and that way it is about 260 grams. Let's say about 200 rupees per ton, and the total maintenance cost in fact will be about okay, I have the figures of the maintenance cost including our manpower. That will not give a proper these things, but we'll have about 100 rupees, 1800 rupees per ton. We will have the material cost, and this 200 rupees is for the entire plant. It is not only for rolling mills. It costs, it involves entire steel plant. This what is the percentage of water in wire rod mill with bearing oil? We are having a limit of about 2% maximum, and our centrifuges, they are put under continuous running. And we have got spare tanks also to allow the water to settle in the tanks, and then it can in the shutdown time we try to maximize our removal of water. So maximum we have run with the level of 2% of the water in the wire rod mill.
So thank you, Mr. Mohanty. I think that wraps up all the questions. Thank you very much for your presentation. And we will now move on to our next presenter, Mr. M.M. Gadre, Chief General Manager, IC Rail and Structural Mill, Roll Turning Shop, Roll Pass Design Bureau and Plate Mill, Steel Authority of India Limited, Bhilai Steel Plant. So over to you, Mr. Gadre. Mr. Gadre, can you hear us?
Good evening, Ankit. I'm just trying to share my slides.
Yeah. Yes, we can see.
Can we shift it to the slightly left side?
So right now the slide is not in full screen. Can you make it full screen?
1 minute. Yeah. So good evening, Mr. Mukherjee, Mr. Sharma, Mr. Mohanty, and Mr. Ankit. Bhilai Steel Plant, a symbol of Indo-Soviet techno-economic collaboration, is one of the first 3 integrated steel plants set up by Government of India. It was built up just to create a sound base for the industrial growth of the country. So at that time, the capacity was 1 million ton. Later on, it was expanded to 2.5, then 4 MT, and now we are touching 7 MT. So the rolling mill complex consists of blooming mill, billet mill, rail and structure mill, merchant mill, wire rod mill, plate mill, bar and rod mill, and universal rail mill. The rail and structural mill and URM, they produce rails, whereas plate mill produces flat products, that is plates. Now these are all the commissioning dates. when the commissioning started. We'll talk from the mills. The commissioning of BBM took place in 1959. It was looming as well as billet mill. And then RSM in 1960. Then merchant mill, it came in 1961. Wire rod mill came in 1967. Plate mill came in 1983. And the latest, our URM, it came in January 2017. And the BRM, that is the bar and rod mill, it came in 2019, January 19. So now we have stopped the blooming mill, but I would like to tell to the entire audience that the blooming and billet mill, popularly known as the mother mill, was primarily designed to roll 2.5 million ton per annum of ingots into semis. At that time, this mother mill was supplying blooms for the billet mill, and these billets were then becoming the raw material for wire rod mill and our merchant mill. And the blooms, rolled blooms, were then supplied to rail and structural mill, where rails and structurals were being made. Now this mill is stopped right now, and now we are getting the blooms from continuous casting route. So SMS2 is feeding to rail and structural mill and partly to URM. And now we have SMS3 also, which is producing blooms as well as billets to cater the need of URM as well as BRM, wire rod mill and merchant mill. Now we'll come to plate mill. Plate mill was commissioned in 83. It's a 3,600 millimeter. It came under 4MT expansion of billet steel plant. It's a long mill covering a length of 1 kilometer. The mill was designed for annual production of 0.95 million tons of finished plates.
Mr. Gadre, sorry to interrupt you. So your screen is stuck on the first slide.
Give me 1 minute.
Yes.
Next. Is it okay now?
No, it is still on the first slide and it is not full screen.
Sir, now it is okay?
It is not in presentation mode, but can you just change the slide?
Just a minute. It is now it is in the presentation mode.
No, it is not showing in presentation mode.
I think, Mr. Gadre, you'll have to switch to, where you can go to view and go to, or you can go to slideshow mode. Just click on the slideshow mode.
It is in slideshow mode.
So I think what you can do is, instead of sharing the PPT, then you can share the entire screen and try that. Sometimes that works.
So it is not moving down.
No, no, no. Maybe you can share the entire screen instead of the PPT, and then it might work.
Just a minute. Just a minute.
Yes, yes.
जल्दी शेयर करते हैं, थोड़ा साउंड
चल रहा है। हाँ, चल रहा है।
ये मेरा साउंड क्या करूँ?
Hello, sir.
Hello,
Yep.
is it okay now?
It is not full screen yet, but can you, but it's okay. We can work with this as well, but as long as we are able to change the slides.
It is clearly visible, no, sir?
No, it is not in, it is clearly visible, yes, but it is not in full screen mode.
Okay, full screen.
But it's okay. Can you just go to the next slide?
Okay, okay, sir.
Just to check if it is.
Is it changing now?
No. The slides are not changing.
Not
But,
yet?
but here it is changing.
So I think it is sharing the, so sometimes what happens is PowerPoint creates two different windows and it is sharing the original window and not the full screen window. So maybe you can turn off the slideshow mode and then try changing the slides. Yes, now it is changing. So I think we can keep it like this. Yes, now it is changing.
It's changing, okay.
Yes.
Okay, so I will start again. I will start from the commissioning dates. So these commissioning dates, you can see here, the blooming and billet mill was commissioned in 59. Then rail and structure mill in 1960, merchant mill in 61, wire rod mill in 67, plate mill in 1983, and the latest URM and our BRM, they were commissioned in 17 and 19 respectively. Blooming and billet mill, is it okay now?
Yes,
Hello?
yes, it's perfect. Yeah.
Blooming and billet mill, which is stopped right now, but it was known as mother mill because it was catering the need of all the mills at that time. Then with the operation of SMS2 in offing, then blooms, casted blooms are supplied. Now rails are being made through SMS2 route only. And with the starting of SMS3, BBM as SMS1 route has been stopped. So now SMS2 and SMS3 are meeting the requirement of URM, BRM, wire rod mill, merchant mill, and RSM. Now we come to plate mill. It was commissioned in 1983. It's a 4 million under 4 million expansion program, and its mill is almost 1 kilometer in length and produces 0.95 million tons of finished plates in 5,600 operating hours. The capacity got further enhanced to 1.3 million ton with the addition of new cooling bed, 2 pilers, and replacement of 1 side trimming shear. Now we come to rail and structure mill. The capacity, design capacity of RSM is 7.5 lakh million tons of rails plus structurals. The structurals produced were angle 150, 200, then beam 250, 300, 400, 450, 500, 600, channel 250, 300, 400. Then rails, the earlier profile was UIC 60. Then we have the capacity to produce thick web asymmetric rails. Then copper moly corrosion resistant rails, which was later modified to nickel copper chrome alloyed rail. Now the weldability test of these rails are being conducted right now. Once this is established, then railway will be taking these rails from us. Already they have got a requirement for this. Then we have vanadium micro alloyed rails. These are for better wear properties, wear resistant properties. And right now we have switched out to new profile, that is 60E1, and the grade is also R260. So here the UTS values and YS values are better than 880 grade, the earlier grade of rails. Now here I am trying to show the asymmetric rail. This kind of rail we produce, and it has been designed in our roll turning shop, the roll geometry, etc. And we are producing this rail, and then we are enforcing it to make the end suitable to, so that it can be welded with the normal UIC 60 rail. So there's a demand for these kind of rails for making the switches. So this in this financial year, we have supplied almost 800 tons of these rails to Indian Railways, and 300 tons are still left with us to be supplied. Then we come to merchant mill. The merchant mill is a 350 millimeter semi-continuous high capacity mill designed to roll 5 lakh million tons of finished products per year. Here we produce the round bars of 28, 32, 36, 40, 50, 53, 56 millimeter diameter. Then TMT bars 28, 32, 36, 40. Angles also 50, 65, 75, 80 and 90, and channels also. Then we come to the universal rail mill. This is the latest mill which was commissioned in 2017 to produce rails of 130 meter long. And we weld these rails to make a panel of 260 meter long. The rated capacity of the mill is 1.2 million ton. Presently, the mill is in ramping up stage. And so far, the mill has produced rails of UIC grade 880, 60 grade. Now we have started manufacturing 61 profile of grade R260 since April this year. Now efforts are on with the OEM and OES SMS Mir to produce the rails of grade 1175 HT. There's a demand for this kind of heat treated rail. It's an European specification. So the mill receives input from casters of SMS3 of size 300 to 335. Now here I am showing the difference between the normal rail mill and the universal rolling concept. These two are the two high mill of RSM where the rail is being produced. And this is the universal rolling concept. We have two horizontal rolls and two vertical rolls. So that way the rail is being produced. So here the bloom, you can see here the bloom is deformed from all the four sides. So the grain structure is good. Residual stresses has gone down and the properties are also improved. And it is very easy to adjust the section here because all the four rolls can be moved independently. We have got a hydraulic screw down also here. So that is the another advantage. So the capacity of this universal rolling mill is 1.2 million ton. Then we come to the new mill bar and rod mill. It was commissioned in January 2019 with a rated capacity of 0.9 million ton per year. Presently, the mill is also in ramping up stage. And so far, the mill has produced wire rods of diameter 5.5 and 7 millimeter. TMT bars are regularly, we are making 10, 12, 16, 20, 25, 32 millimeter. The mill receives input from the casters of SMS3. So now BBM route is totally stopped. SMS3 is getting the requirement of URM, wire rod mill, merchant mill, and BRM. And SMS2 is partly URM and RSM. Now, all the mills had joined at different point of time. So they had the associated equipment suiting to their requirement at that point of time. Mill configuration, nature of equipments, and the method of their actuation is different for all the mills and were latest at that point of time. As the technology got involved with the passage of time, conventional drives have been replaced with the latest digital ones. Electromechanical actuators have taken a backseat, and electro-hydraulic actuators are being preferred to have better control on speed, force, and position. Automation has helped in achieving consistent and improved production with quality and safety. Now we'll come to the major equipments of any rolling mill. So these are the roller tables to receive the input material. Whatever input material which we are getting, we are receiving on the roller table, and that becomes the input route for our reheating furnaces. Then we have reheating furnaces. Once the input stock is rolled, is heated, then it comes on the roller table, and which are feeding to the rolling stands. Then we come to the roller table for transportation of the rolled stock. Finally, we have cooling beds, transfer beds, straighteners, levelers, and inspection beds. Now, a lot of innovations and modernization have taken place in the areas of reheating furnaces, rolling stands, bearings, hydraulics and pneumatics, and lubrication. And this has brought some changes in the maintenance practices. So now we have the maintenance practices of reliability centered maintenance, then preventive maintenance, that is routine, time-based, then minor repairs and capital repairs. Mr. Mohanty has gone in details of this, so I will not be covering it much. Then we come to the reheating furnaces. Here, till the URM and BRM came, we had all the furnaces of pusher type, and the latest furnaces are walking beam type. So walking beam type furnaces are much better as the skid marks are not there. There are no excess scale generation. There is proper heating regime is very good. So it's a better type of furnace. And our old furnaces are pusher type are still working, but we are trying to phase them out. So recently we are trying to have a new furnace, walking furnace for our RSM, as well as one furnace for our plate mill. Then we come to the operating networks of any furnace, that is the mixed gas network. When we come to the combustion air network, then flue gas network, cooling network, and refractories. So in the mixed gas network, we are receiving the gas, the mixed gas from our gas booster station, which mixes the LD gas, blast furnace gas, and coke oven gas, and we get the gas. So that gas network is has got undergone some changes with the commissioning of URM, because in URM we have got gas as well as a lot of new facilities are there to take care of any kind of means pressure generating inside the gas lines, because in earlier furnaces we had explosion flaps to take care of any flame going inside the gas network because of the drop in the gas pressure. But in URM that is not there. Nitrogen circuit is already there, and through solenoid operated valves, in the event of any drop in the gas line header pressure, nitrogen gets entered into the circuit and it doesn't allow the explosion to take place. So it is an additional advantage. In the combustion network also, in URM as compared to the other furnaces, there are a lot of changes. Slowly we are trying to modify our existing air network of existing mills also. If you go see the flue gas network, here we have got dampers, then dilution air blowers in our new mills like plate mill and our URM. But our old mills do not have these kind of facilities, so we will be modifying them. If you go to the cooling network, we have a different kind of cooling network for our different furnaces. Like say in old furnaces, we have once through kind of skid cooling network, whereas in plate mill we have got evaporative cooling system, and in URM we have got again once through, but the cycle is closed cycle, so we have got heat exchangers. We again take out the water from the skids, and then it is being cooled and then again sent it back. So it's a closed network, only the makeup quantity is being added. And then comes the refractories. Lot of innovations have been in the refractories, and which we are changing as and where we find the place to do. Like say in plate mill also, in the hearth area, we have gone for new refractories also. Now we come to the stand housings. We have different type of stand housings, like say open top type. In wire rod mill, in merchant mill, and in RSM, we have got stand housings of these three types. Recently, housingless stand is being used in merchant mill in 3 stands to take care of rigidity, because we wanted to roll the bars in negative tolerance, which was earlier not possible with open type kind of housing. So we have put housingless stands in 3 locations. These offer more rigidity, so that we are in a position to roll the bars with negative tolerance. Then we have closed type of housings. These are in RSM and in plate mill. And lastly, we have detachable type of housing, which is there in URM, where roll changing is much faster. So we have all these different type of housings, and all these different types have different requirement of maintenance. I would like to show a picture of this, how in plate mill we have converted our axis mill into an offset mill, because there were a lot of issues with the housing, and the housing window got enlarged to that extent that it was difficult to roll low thickness plates. So in 2008, we have converted this axis mill. You can see here, earlier the backup, it's a 4-high mill. Both the work rolls and both the backup rolls, they were all rotating in one single plane. The axis of rotation was in single plane. But now we have made the mill, we have converted the mill into an offset mill by 12 millimeter. So the axis of rotation of this work roll is different and backup roll is different. This has helped us in the axial loads, which was coming earlier when we were rolling low thickness plates, and the arrestor plates that were getting damaged, and rolls were simply coming out of the stand. So with this modification, we were in a position to roll even 8 millimeter thick plate. But of late, the again stand geometry has gone bad, and we'll be going for a major capital repair in plate mill for this geometry correction of the stands. So I just wanted to show how an axis mill got converted into an offset mill in 2008. Then we'll talk about rolls. Different mill has got different material of rolls to take care of the requirement. And the basic idea behind purchasing or developing any vendor is to that resistance to fire cracks and the drop in hardness. We have got rolls of different materials with us. And when we do the dressing of these rolls, we take care to remove the work hardened layers, and we give the crown required for a rolling point of view. This is specially done with the flat rolling. Whenever we are taking out the rolls from our plate mill rolls, we do give crown in the work roll as well as in the backup roll. So because of the roll separating force, the crown gets tried to get straightened. So we get the comfortable this thing. There's no variation of thickness across the width. Then we come to the assembly part, checking of bearings and chokes, proper locking and adjusting of axial movement. This is being done in the assembly of rolls. And then we come to the cooling of rolls, because cooling is very important. Whenever we are doing rolling, roll gets heated up. And if we maintain the rolls at a particular temperature, say 50 to 60 degrees centigrade, then a thermal crown is being maintained, which helps in getting the section. So cooling is very important. And in the plate mill, we are having flat jet nozzles of Leclerc make. We have specially designed the headers to cool the rolls in that way. Then we come to the pass lubrication. To control the pass-way route, we are spraying the oil in the passes, of, especially in rail mill and URM, and we are getting good results out of it. So that way we are maintaining the rolls. Then we come to the bearings now, because bearings are such a thing which is, it's kind of machine elements which support and guide the components which turn related to each other. So we need to maintain them. We have got 3 different kind of bearings, journal bearings, then anti-friction bearings and hydrodynamic bearings, especially in the stands. But as our mills are quite old, like our Blooming and Billet mill, which was stopped, then our rail and structure mill, we here have these non-metallic bearings. These are textolite bearings. So these are, they offer very low coefficient of friction. They are water lubricated, and we are very much comfortable with using these bearings in our intermediate stands. Whereas in finishing stand, we are using anti-friction bearings. And as far as the hydrodynamic bearings are concerned, these bearings are used in oil film bearings. These oil film bearings are used in our backup rolls of plate mill as well as in wire rod mill. So these bearings are suitable to take care of very heavy loads. And when the radial clearances are much less, these bearings can be easily accommodated as compared to the anti-friction bearings. So in plate mill backup rolls, we do have these hydrodynamic bearings. Then we come to the maintenance of bearings. Whenever we are carrying out the maintenance of bearings, the initial step is that we have to handle with proper care, because these bearings, they should not be exposed to airborne contaminants. They should be properly wrapped up with proper preservative. Then when we are going to install it, install the bearings in any of the location, then we need to check the bearing housing as well as the shafts. Any kind of nicks and burrs are to be removed. And the bearing seating surface should be properly clean and should have a finish of almost delta 3. Then at the time of mounting, we see that how we are inserting the bearings on the either on the housing or on the shaft, and we have to take proper care not to hit the races so that they are being maintained properly. Then we come to the heating part. We need to heat the bearings prior to installation, but this time we should use the induction heater, and we should not heat by any open flame. We should heat it by induction heater, and we should try to maintain the temperature as recommended by the supplier. We should go for proper use of tools like say bearing pullers, fitting tools, then hydraulic nuts, some induction heaters. We have to use them. We must avoid the corrosion, the bearings getting corroded. They should not be exposed to any water or steamy atmosphere. And the last and not the least, the proper lubrication. To improve the life of bearing, we need to lubricate them, and there should not be any starvation of lubrication, starvation of any lubricant for the bearings. Then we come to the different hydraulics and pneumatic systems which have come in our rolling mills. When we started our mills way back in 1959, at the time the use of hydraulics was very, very less, especially in our merchant mill and our blooming and billet mill. But slowly, when in 1967, when railroad mill came, a lot of hydraulics was there, especially in stands, especially in our decoiling and twisting unit. Then in 1983, our plate mill was commissioned, and here almost all the equipments had something of hydraulic to play a role, important role. I can give you an example that in roll balancing, so plate mill, our rolls are very heavy rolls. It's a 4-high mill. The weight of our work roll is almost 80 tons, and the weight of backup roll assembled condition is 275 tons. Here the rolls are hydraulically balanced, whereas in the older mills, these rolls were counterweight balancing system was there. So now these rolls are hydraulically balanced and very compact and very small diameter cylinder, say 340 millimeter diameter cylinder is able to balance the entire top roll assembly, and the system pressure is hardly 170 bar. So we are in the position to balance that. And then in the slab extraction system of plate mill, then in cooling beds, then inspection bed, then pilers, then in trimming shears, everywhere hydraulic is being used. And now with the latest generation of mill, that is URM, here a lot of hydraulics has come, a lot of new generation walls, proportional walls, servo walls are being used, and precise control in speed, position, force is getting achieved with use of this. So for maintenance of a hydraulic system, the filtration is very important. We need to have offline filtration. We need to have ELCs, that is electrostatic cleaners. We need to have return line filters. We need to have pressure line filters just to maintain the NAS value as desired by the, or as recommended by the supplier. Then we come to the maintenance of pumps, valves, and accumulators. So these are to be maintained. If we can maintain the filtration part, almost 96% war is won, because most of the damages are only because of the contamination. Then we come to the maintenance of actuators. In hydraulics and pneumatic system, we have two kinds of actuators, that is linear actuator and rotary actuator. So linear actuators are cylinders, and rotary actuators are hydraulic or pneumatic motors. So these we have to maintain them. We have to check their sealing system. We have to constantly check their fittings, their mounting, and the proper alignment also. Then we come to the lubrication system. Like other plants also, we have got 3 lubrication system: grease lubrication, oil lubrication, and oil air lubrication. This is the latest lubrication system, oil air lubrication, which has just been introduced in our URM, and now it is there in BRM also. So in grease lubrication system, we have got the dual line centralized grease lubrication system and manual hand pump operated system. We are using grease of NLGI 1-2. It's lithium based and calcium based also. And these dual line grease system, we are maintaining it. It's a centralized automatic grease system. We need to maintain the end pressure relays and the settings of the pump. So continuous, by adjusting a timer, continuously these grease systems work, and grease is fed in doses to the feeding points. There are certain locations where system cannot supply the grease. So for those locations, and where the frequency is very low, we go with manual hand pump operated system. Then we come to the oil lubrication system. It is there in every mill. We have got a very different kind of hydraulic, lubricating oils which are being used of different viscosities, starting from viscosity grade 100 up to 1000. And for oil film bearings also, we are using servo steel 257 and servo steel 460 oil for our Morgoil bearings. Then the last one is the oil air lubrication. This is a new system which has been introduced in URM. I would like to go in detail of this. It's a system which has been supplied to URM by Rebs, the German company. And in this system, the air is being used to transport the oil to the lubrication point. So what happens, oil at a higher pressure is injected in the pneumatic line, air line, and which carries the oil droplets to the feeding points. So with this exact dosing of the oil quantity supplied to each lubrication point is achieved. The protection of the lubrication point against penetration of contamination through air or pressure, because the bearing is always filled with air pressure. So there are no chances of outside contamination, or even the cooling water can get inside the bearing, and we get a good life out of it. Then it is very easy to monitor, because we have got turbo loop kind of monitors which give feedback that oil is not going. So immediately action can be taken, and oil dosing to the different bearings can be monitored. In URM, the bearings of rolls of breakdown stand and tandem mill stand are fed with this kind of system, and almost 4 years have gone, and we have seen the bearings are in very good condition, and till date we have not changed any bearing for this lubrication starvation point of view. Then the air speed is approximately 10 to 30 meters per second, and the oil speed is approximately 2.5 meters per second, and the consumption is also very low. Here we are showing these are the turbo lube lubricators. In the doses, they are feeding the lubricant to the different bearing points. So this is a new system which has come in BSP in URM in 2017, and now it is in BRM also. And I just wanted to share this new system. So that is all from my side, and if you got any questions, I am ready to reply to them. Thank you.
Thank you so much, Mr. Gadre. Is there any other questions? Any questions for Mr. Gadre? So I assume Mr. Gadre has given a thorough presentation on the entire. Mr. Gadre, in fact, is the CGM of Bhilai Steel Plant, who heads the rail and structural mill. And you know, the rail mill is, or Bhilai is, I would say, the pioneer when it comes to rail mill in India, along with JSPL, who came later than Bhilai. But JSPL has started producing head-hardened rails. Mr. Gadre, when is Bhilai likely to start producing head-hardened rails?
We have got that facility of 1080 HH head-hardened rail, and right now we are associating with our OEM and OES SMS mill. Trials are being conducted, and results are quite encouraging, and very shortly we'll be in a position to produce 1175 ST rails.
Thank you, Mr. Gadre. Thank you so much. And please convey my regards to entire Bhilai team and my good friend, Mr. Anirban Gupta, your CEO. My special regards to him. And Bhilai has always been, we all know that Bhilai is the flag bearer of SAIL. So of all the SAIL plants, we always believe that Bhilai is the flag bearer of SAIL. So Bhilai has taken SAIL to a different level altogether. So I wish you and Bhilai all the very best, and thank you so much. So
Thank
Mr. Hari Narayan, before
thank you, Mr. Mukherjee. I will definitely convey your regards. Thank you.
Thank you so much, Mr. Gadre, and please stay with us for some more time. We have a very interesting event today. I would call it a special event. This morning, I was there for a press meet with Mr. Harsha Kadam, who's the MD and CEO of Schaeffler India. So they have, in fact, inaugurated a large-size bearing refurbishment unit at Jamshedpur. So the managing director of Schaeffler India, Mr. Harsha Kadam, with us. So I'll take the liberty, Mr. Ajay Kumar, since Mr. Harsha Kadam has to leave back, so he has to travel back. And so I need little liberty from you. And Indian Oil being so special to us, I would take the liberty of giving that, your slot, I would say, to Mr. Harsha Kadam, because we'll come back to it, because he's going to finish early anyway, because he has been through a very hectic day right since morning with the inauguration of the refurbishment center at Jamshedpur. Since it is a very special occasion for Schaeffler bearings, we decided to invite Mr. Harsha Kadam today to celebrate the great occasion where almost, I think, 10,000 square feet of refurbishment center has been put up at Jamshedpur. And as you know, Jamshedpur is better known as the steel city of India. So with that, Schaeffler proves that they have a special love and affection for the steel industry. And no rolling mill could move without the bearings which Schaeffler would be giving us. And the huge loss which the steel industry would be facing in case we do not have adequate refurbishment facility for our bearings, which goes through so much of wear and tear. And since, which I just mentioned when Mr. V.S. Sharma was speaking, today, when the steel industry is ramping up its capacity to our movement towards 300 million tons from a level of 110 to 120 million tons. So we'll be adding about 180 million tons of steel capacity in this country by the year 2030, which is, say, another 9 years to go. So with that, what is also happening is, and because of the China crisis, China having cut down its production to a great extent, we are heavy pressed. We are under serious stress to produce more and more. And when you do that, you push your rolling mills to the edge. You push your mills, your casters to the edge, and it has to perform beyond its nameplate or rated capacities, which means the bearings has to go through more and more wear and tear. So with that, please allow me to
Sure, sir. We have a very special relationship with Schaeffler Bearings, working with them for developing greases. So please, Mr. Kadam, you may please go ahead in my place. We'll take our slot later on.
Yeah, just after this, Mr. Harinarayan,
Sure,
I also take this liberty from you, since you mentioned that as a tribalist, and as I said, my father was a tribalist himself, who spent almost his entire life with Bamal Lorry, grease division at Bamal Lorry. And by heart, he was a tribologist. And as I mentioned, from our childhood, tribology was something which was like a legacy in our blood. So as a tribologist, I would request you to give us that liberty where Mr.
Please, sir. We are here to reduce friction, and we will allow you the liberty to do so.
Yeah. And IOC is a part. I would call IOC a partner in that progress. And
sure, sir, sure.
As you saw Mr. V.S. Sharma also mentioning that he has been to your R&D center at Gurgaon, Mr. Deepak Saxena, and your director R&D, Mr. Ramkumar. We have been working with IOC team for such a long time. Last year, both Mr. Ramkumar and Mr. Deepak Saxena, both of them were there in our webinar together. So we have Mr. Harsha Kadam and Mr. Kaustubh Mukherjee. Being a Mukherjee, a special welcome to another Mukherjee, Mr. Kaustubh Mukherjee, head of our raw material segment of Schaeffler. So I would like to welcome both of them. And before we move on to what Schaeffler has to offer at their special occasion with the inauguration of the refurbishment center at Jamshedpur, may I request Ankit to please play the corporate video of Schaeffler before we move on to him.
Bearings perform a critical role in operating high-value machinery continuously and efficiently. These bearings, mostly large size, are periodically replaced at the end of their operating life to ensure machine uptime and performance. But today, while replacing, you have a high cost-effective and environment-friendly solution instead of purchasing new bearings. Now you can save such costs by giving these critical components a new lease of life at the Schaeffler large-size bearings refurbishment facility in Jamshedpur. This state-of-the-art facility at Jamshedpur extends the life of your large-size bearings, giving your machines lower downtime, reducing your carbon footprint and savings on buying new and expensive bearings. With its zero-defect policy and acclaimed global standards best suited for various critical sectors, you can trust Schaeffler to return your bearings in mint condition, extending its life and maintaining performance. Schaeffler. We pioneer motion.
Thank you, Mr. Kadam and Mr. Mukherjee. Now, it will be injustice on my part if I do not thank my very good friend, a friend for years, I would say, for decades, Mr. Vijay Chaudhary, who's your head of your corporate communications, a very good friend of mine. So, a good friend of mine for years, even when he was with SKF, we had a relationship, a very close working relationship together. So, my special thanks to Mr. Vijay Chaudhary as well for giving us the opportunity of inviting Schaeffler for this great momentous occasion. So, over to you, Mr. Mukherjee and Mr. Kadam. The floor is yours.
Thank you, Mr. Mukherjee. Truly appreciate you giving us this opportunity. And Ajay, thank you so much for accommodating. Yes, I'm aware that we are working together on a couple of projects. I guess the new one happens to be now hydrogen and fuel cell, and our team is talking to your team. So exciting things in the country, and I believe the synergies that we bring can bring a lot of value to the community and the society around us, not to mention the environment. Yeah. So without further ado, Vijay, if you can share the slide, please. I hope you can see the opening slide.
Absolutely.
Yes.
Great. So for today's event, and thanks for inviting us once again, we have called it Advancing Sustainable Motion and Mobility. What do I mean by that? When I take you through the presentation and when Kaustubh explains the essence of what we do today, you will understand the meaning of this. And particularly, we are targeting the steel mill maintenance and the lubrication part of it, so to say. Next slide. So, but before we get into that, I thought I'll let you a brief about what is Schaeffler globally. As you can see, we are a large company, a German multinational, present in 50 countries, 200 locations across the 50 countries, with a global turnover of roughly about 13 billion euros last year, 84,000 employees working for us globally, and with 75 manufacturing plants across the world and 20 R&D centers distributed across the world. Strong customer base, and as you can see, the best part is here that we are one of the largest consumers of steel. And these are very special bearing steels that we use. Almost close to 1 million tons of steel we consume every year, because in a bearing, it's almost steel. Next slide. Having said that, we are a company that believes in having a purpose, a vision, and a mission. And our purpose is that we are big innovators of new technology when it comes to the mobile applications or the static applications. What do I mean by that? Be it the mobility segment like the automotive applications, or the non-mobility segments like the raw material sector, steel, cement, mining. Now these sectors too use a lot of bearings, and we come out with innovative solutions so that we continue to pioneer motion to advance how the world moves going forward in future. With that, we have set clear plans for ourselves. How do we be able to serve that purpose? And clearly, we have targets set. And one important target, which I will come to now, is the carbon neutrality or climate neutrality announcement that Schaeffler has done globally by the year 2040. Our CEO has announced that Schaeffler globally would become totally carbon neutral by the year 2040. Why is that? As you know, sustainability plays a key role in implementing our corporate strategy. And the decarbonization of Schaeffler Group by 2040 is a very big priority for us right now. So very clearly, through our defined targets and specific measures, we are doing our part to help achieve the objective of the Paris Climate Agreement. As you all know, our Prime Minister was in the COP26 meet last week, and he has officially announced that India too would become climate neutral by the year 2070. However, the Western countries have set a far more aggressive target, and in line with that, rightfully, so has Schaeffler set itself. Now, one may be wondering, what's the connect between this and what I'm going to talk next? Well, the connect is, as you all know, steel is one of the largest, carbon emitting industries in the world. And so there is a lot of effort by the developed countries to see how do we produce green steel. And I'm sure you would have read in the papers last week, a Swedish startup has now come out with a technology to manufacture green steel, which means they will produce steel totally from green energy. Having said that, Schaeffler, we have gone ahead and got into a contracting arrangement with them to source 100,000 tons or 1 lakh tons of green steel for our bearings going forward from the year 2025. So we already started to engage with them and work with them. So clearly, what drives our business is our commitment and belief that we want to play a big part in the efforts towards climate neutrality. So with that, a little more about information about what are we in India today. We are present across the country, as you can see, with 4 manufacturing facilities, 2 of them being in Gujarat, 1 in Maharashtra in Pune, and the 4th one in Tamil Nadu, Hosur. We also have 2 R&D facilities, 1 in Hosur and 1 in Pune, and with about 2,800 employees on board, 4 plants, 2 R&D centers, with about 90,000 square meters of manufacturing footprint that we have in the country. Clearly, we are focused on a localization drive. Every year, we invest in capacities and make efforts to localize the products which erstwhile continue to be in. Currently, last year when we ended, we have closed the year with about 76% of localization. And as you can see, we consistently spend on R&D. And in the last 5 years, close to 250 crores we have spent towards the R&D effort to develop new solutions in line with our adage, we pioneer motion. Just to give you some more flavor of what markets do we play in, the entire automotive application market, be it the engine system, the transmission system, the chassis system, or for that matter, the emerging hybrid and electric drive systems, we are there. We have a variety of product offerings to go into all these applications. Look at the aftermarket business. Again, the automotive aftermarket, we are catering to every sector of application. Plus, we have now started to launch new products, and like lubricants is one of them. Last year, we launched the engine oil lubricants and moved on to hydraulic oils as well, which has been very well received in the marketplace. We will continue to add more products under our Schaeffler True Power brand under the automotive aftermarket space. Now, coming to the industrial sector, as you can see, a variety of sectors there: wind, aerospace, off-road, power transmission, raw materials, railway, two-wheelers, and industrial automation. Now, having said that, just by looking at the sectors, you can imagine the variety of the products and the range of products, the portfolio for industrial application. Moving on, I come to the core subject today. Thank you, Mr. Bedrick. When I was listening to your presentation, I heard you talk a lot about how important a lubricant is, and Ajay, you said it right, that lubrication is so critically important to the bearing. A bearing cannot function without a proper lubricant, right? And but we do still end up having failures in the market. Our customers end up using the bearings, but then somewhere along the way, the bearing begins to deteriorate. From my experience, if a bearing is properly taken care of with good lubricating systems, good lubricant, the bearing should be running eternally, but that's not the case always. The harsh reality is the bearing has a life of its own, and considering the extraneous factors which are beyond our control, there is bound to be some early failures beginning to emerge in the bearings. So just imagine in a steel mill that you begin to have expensive bearings which begin to fail early. And to replace those bearings, the cost is high. To carry inventories of those bearings, the inventory cost is high. So to do that, we have been working here, and we have now established a center which is going to look at to refurbish the bearings which have started to wear out. And with that, we are able to extend the life of the bearing going forward so that our customers get the value of an extended life from the bearing. And this to us is a very economical and sustainable solution, exactly in line with the strategy that I talked about in our journey of carbon neutrality. Now, one interesting point here, if a customer were to see that a bearing fails and if he were to replace it with a bearing, let me take an example, a 2-row taper roller bearing, and if that bearing were to be replaced, the cost, the carbon emission that we have is so huge because of the energy required to produce the bearing. Whereas compare that with the bearing that I refurbish, I would be saving 49 tons of carbon dioxide emission in the life cycle of that bearing. So that's the advantage. So ultimately, the higher objective, bigger purpose here is how do we contribute towards the reducing the carbon emission. And this is where our refurbishment center comes in, adding a huge value to our customer base. Next slide. So we have joined hands with Premier Bearings here in Jamshedpur, and with that we have inaugurated the center today. But this is not something new to Schaeffler. Globally, as you can see on this slide, we have been doing the refurbishment activity all over the world. And India, there was a gap which we have now plugged. We have a center which has started up now here. And there are various levels of refurbishment that we carry out. And going forward, we believe that for the steel industry in this part of the world, this is the value as Schaeffler would like to bring, contributing to the larger value of reducing carbon emission. And with that, I would like to hand over to Kaustuv. Kaustuv would take you through the next few slides and talk a little bit about, a little on the technical side, what does this refurbishment? Over to you, Kaustuv.
Thank you, sir. A very good evening to everybody. Good evening to Mr. Mukherjee, Mr. Hari Narayan. Wonderful to see you there, Mr. Ajay. And to carry forward what Mr. Kadam had been speaking about, basically Schaeffler has almost all the solutions imaginable for steel mill applications. For the primary applications that you can see in the slide, converters, continuous casters, the hot rolling mills, the cold rolling mills. So we have a huge range of product variety for all these applications. Application specific, we have various designs. We have a category called X-Life premium products, which is typical for Schaeffler, which where we have a higher dynamic load rating, and load ratings are higher, so you get a higher life with these products. That is Schaeffler patented X-Life premium products. Then we have various services for our various rolling bearing applications in steel. We do condition monitoring, the reconditioning that Mr. Kadam just spoke about, which we have launched now. The various mounting services. We are into roll shop services in steel plants, lubrication. So these are the various services that Schaeffler is specialized in, covering almost all applications in a steel mill. And of course, Industry 4.0 solution, which is very important to Schaeffler and which is one of our prime goals, which is contributing not only to reduce the production downtime in steel plants, but also in the other industries that we spoke about in the previous slides, cement, mining, almost any industry. So Industry 4.0 is a very key area for Schaeffler. Now coming to the product offerings, coming to this particular reconditioning project that we have launched, basically we will be covering almost various products that are there in our portfolio: ball bearings, roller bearings, 4-row CRBs, 4-row TRBs. Almost every product will be covered. And further, we are also offering our various maintenance and service offerings, Industry 4.0. As you can see in the second portion of the slide, various pumps, then coolers, condition monitoring equipments, then you have the automatic lubricators. Then there are, in the last, you can see the Smart Check, which is our online condition monitoring tool. You have Optime next to that, which is the latest launch in online condition monitoring. And ProLink is also there. So various condition monitoring, online condition monitoring, lubrication and reconditioning services that we offer can be seen there in that slide. So these are our product offerings. Now coming to the reconditioning facility that we launched today, which Mr. Kadam spoke about. Primarily, the following steps would be covered in the operations that we will be doing here. The first step would be cleaning. So all components that arrive here would be thoroughly cleaned, as you can see. So that is the first step. And after cleaning, it would be possible to examine the components. So we have various instruments here, various equipments have been already are in operation, high precision measuring and inspection equipments for crack detection, thickness measurements, ovality checking, and various other examinations will be carried out to decide on the next steps. So after that, a complete and detailed proposal and report would be prepared on the examination that has been done here. Subsequent, yeah, no problem. Subsequent to the proposal and based on the feedback that is provided, the next surface working would be decided where the running marks, corrosion, or any other defects that would be there would be removed by either polishing or soft grinding methods. So this is the actual working that would take place in case the need arises for doing that. And after the surface working is done, various measurements would be taken, all dimensional measurements, and more importantly, the clearance, axial, radial clearance, and that have been impacted, hardness testing, and to determine whether now it is in line with what is required by the customer. And as a final step, after everything is over, the load zone marking would be done, and preservation, assembly, packing, everything in line with what Schaeffler standards are there for a new product would also be implemented for the reconditioned product. And of course, then it's good to go, delivery and monitoring. And of course, as a last step, we will not leave it after delivering the reconditioned product to the customer. A continuous monitoring by our team would also be done to ensure that we fulfill our promises that are and expectations of the customer. So this reconditioning shop, what would we be doing? So we will be catering to almost all the major bearings that are there in our portfolio, in Schaeffler portfolio, like full complement cylindrical roller bearings, that is the bearings without cage, spherical roller bearings with brass cage, steel cage, all spherical roller bearings, 2-row taper roller bearings, 4-row taper roller bearings, the roll bearings which are used primarily in wagon application, cylindrical, spherical, of course the 4-row CRBs primarily for long product mills, and okay, that cylindrical roller bearings with steel cage. So currently we would be covering a outer diameter range up to 1 meter, but we will definitely be going much ahead of this with time to come. And the various sectors, I mean, this reconditioning shop, although you can see only 6 sectors that are there, they are steel, power, pulp and paper, cement, mining, and railways, but I'm sure this will be covering many more sectors. We are open to almost any application that where we could serve our customers. So now, basically, this is a technical slide, and how do you decide when to refurbish the bearings, or when do you decide not to refurbish the bearings? So if you look at the left side, the graph, the y-axis shows the bearing life, and the x-axis is basically the time in service. So ideally, if you see with 100%, when you start with a new bearing, you have 100% of bearing life. Now, it will never achieve 100% practically because there are a lot of extraneous factors, like improper lubrication or environmental conditions, hazardous conditions, operational issues, etc., etc. So you would be achieving a life somewhere lower than 100%. 50 is only an indication. It may be anywhere lower than 100%, 80, 70, 60, whatever it is. Now, when life comes down, where you can see the next dotted lines. So that is where you decide to go for refurbishment. And with refurbishment, after the refurbishment is completed successfully with a reconditioned bearing, you would achieve a bearing life in between or closer to the full bearing life, depending on the condition of the bearing when you start the reconditioning. So you would be again starting at a 60 to 70% or 80% bearing life. So it's that is how you extend the resources, or you extend the operating life of the bearing. Now, how do you decide when we should refurbish the bearings? As you can see in the right side of the slide, the first portion is a normal wear zone, which is absolutely normal, and that wear zone, that wear is very normal, it will happen. So there the performance will be in line with the expectations, and you can continue to use the bearing. The middle portion is when the wear zone starts to increase beyond the acceptable levels, and that is when the performance starts to decline. But then the performance is not so bad that you discard the bearing or you replace the bearing. So that is the ideal phase where you decide to recondition the bearing. And how do you decide that? That will come only by predictive maintenance or the experience or regular inspection. So this is the portion where you decide to recondition the bearing. And if that is not done on time and it enters the third phase, which is the severe wear zone, so this is where reconditioning would not be possible or practical or feasible. And there you have to replace the bearing with a totally new bearing. So this would be the analysis of when to recondition the bearings in terms of time and service and the condition of the bearing. Now, what are the benefits? I'm sure most of the audience here are steel mill experts and they know everything about it. What are the benefits? Increase in operating life. So from 100, it would go to 170 with not so much increase in cost. Shorter lead times as compared to procuring or manufacturing a completely new bearing. Of course, reduction in inventory costs, reduction in life cycle costs, and savings in material and energy costs. This is what Mr. Kadam spoke about in the previous slides regarding CO2 savings, and this is a huge benefit. Savings in material and energy costs. The bearing after reconditioning would be ready to mount, going to the customer as a return shipment, and reduction of the CO2 footprint is also what Mr. Kadam spoke about. So this is a reduction of the CO2 footprint is something which is very dear to Schaeffler, and although it's mentioned in the end, but this is one of the key objectives for us in initiating this reconditioning initiative. So that is all from our side. I mean, anything, any questions or anything we could discuss further, please do let us know.
Thank you so much, Mr. Mukherjee and Mr. Kadam. Really appreciate your presentation today. I was there this morning for the press meet as well. So, in fact, when I was going through the presentation, one question just struck me, for which I would request my son Ankit to perhaps put in his thoughts as well. Ankit, are you there?
Yeah, I'm here.
Now, my question is, if you have noticed, when the bearing goes through, lubrication challenges related to environmental pollution, and a steel plant in earlier days, in early 90s when I started my career, I remember a steel plant was not at all a clean work environment to work in. Now, when you see the modern day steel plants, either in Europe or in India for that matter, when you go to JSW at Toranagallu, Bellary, or you go to Tata Steel cold rolling mill complex, you see a different environment altogether. But with all that the bearing goes through, one thing, did you notice Mr. Mukherjee pointed out, Industry 4.0 plays a very major role. So what we need is to find out the data when it comes to condition-based monitoring. What is the condition of the bearing? And you need to know online. So do you think Industry 4.0 will continue to play a major role when it comes to judging the condition of based monitoring when it comes to bearing? And these bearings, remember, in a steel plant, the bearings are not small bearings which you use in the automotive sector. These are huge bearings and very expensive. So when you do the bearing, it's actually a huge loss on your maintenance budget for the year. So what are your thoughts on this, Ankit?
So I think right now there are a lot of edge computing devices coming up. These devices you can set up right at the right next to the equipment or attached to the equipment, which is constantly monitoring the equipment, be it whatever it is, be it bearing or anything else. You can monitor the condition of the equipment, and if anything goes wrong. And there are also sensors that take images and audios and videos of the devices. And you can use these to create a model that can instantly detect if there is something going wrong. And that is, I think, quite useful. So Industry 4.0, not only Industry 4.0, but if you consider as a whole artificial intelligence, machine learning, aspects that can be integrated into edge-based devices, it's quite useful for maintenance.
Yeah, exactly. Mr. Mukherjee, why I mentioned my son and why I invited him was primarily Ankit is doing his, he's just actually finished his master's in data science. And he's based in the city of Magdeburg, which is about 1 hour from Berlin. So he lives in the same country as that of Schaeffler's headquarters. So that's one reason why I thought it's important for us to understand how important Industry 4.0. In fact, the last webinar we did was on Industry 4.0 for the steel industry. And I always keep saying that no one uses IT as much as steel industry does. So because it is so capital intensive, by thumb rule, we say a billion for a million. So produce 1 million ton of steel, you need $1 billion of investment. So going by that standards, the amount of role which Industry 4.0 is playing, we call 3 major big darlings in the steel industry who produce most of the equipment. One is SMS, other is Danelli, and the third is Primetals. These are the 3 big darlings in our steel industry. So all these 3 big darlings, plus the smaller ones like Tenova and others, they are investing heavily into Industry 4.0. So with that, I would request your potential customers from JSW, from Tata Steel, from SAIL Vilai, as well as from Vizag Steel Plant, if they have any questions. So we start off with JSW. Mr. VSN Murthy, are you there?
Yes, please.
So do you have any questions for Mr. Kadam and Mr. Mukherjee?
Yeah, one question. If you can just elaborate on the Industry 4.0 services and the roll shop services, which was told in the presentation.
So roll shop services we are doing in flat products as well as in long products. Complete roll, removing it from the choke, roll grinding, again putting it back. So we are doing it in JSW, bar rod mill, wire rod mill, hot strip mill. We do it in ArcelorMittal also in the CSP, compact strip production mill, and of course in another company, Mukund Special Steel Limited. We are looking at expanding it further. At the moment, these are our projects where we are doing this workshop services.
Okay. Anything on Industry 4.0 services you're doing anywhere?
Industry 4.0, we are primarily to condition monitoring, online as well as offline. So offline, we have a couple of projects we are doing in Hindustan Zinc, Sunflag, and as far as online condition monitoring is concerned, we are doing in the various cement plants, the roller presses. We are doing a couple of projects in steel plants also. And we have a new product in online condition monitoring, Optime. So we are working on that also. So we are primarily into online and offline condition monitoring at the moment. In various
Thank you. Yeah, thank you.
Well, Mr. VSN Murthy is Senior Vice President, Maintenance at Vijayanagar JSW. So thank you, Mr. Murthy. Now I'll move on to Vizag Steel Plant. So Mr. BK Mohanty, who's the Chief General Manager, Maintenance at RINL Vizag Steel Plant. Mr. Mohanty, are you there? Mr. Mohanty? Okay, I think he's not there. Okay, so I'll move on to Mr. Gadre, Chief General Manager, Rail and Structural Mill at Vilai Steel Plant. Mr. Gadre, if you have a question for Mr. Kadam and Mr. Mukherjee. You are muted, Mr. Gadre. Please unmute yourself.
Okay. I've got a question to the representatives of Mr. Schaeffler. Because in plate mill right now we are stuck up with one of the thrust bearings of our work rolls, that is with Russian designation 597/750. It's a thrust bearing. So Schaeffler representatives had come once. They actually want to develop that. So so far they have developed any thrust bearing of Russian designation, because Russian designations do not reveal much details. I think the ghost itself is not quite revealing also. So what is their feeling about whether they are in a position to develop that? I just wanted to know.
Our designations are completely as per DIN standards, thrust bearing or any bearing for that matter. Whereas Russian standards are different, which are there in your plant sale, some of the old bearings which are there. So I will not be able to confirm immediately offhand to you whether it will be one-to-one equivalent we can establish, but Schaeffler will be able to develop any bearing. I mean, we have an internal process called RFQ, wherein if it is not there in our portfolio, any mill bearing, we do a RFQ internally with Germany and we can develop any bearing. But the bearing that you are talking about, we will not be able to identify unless we see it or we see the drawing. So what we will do is I will get in touch with you after this conference, and the drawing that you would send, I will discuss it with my technical experts also, and we will revert to you quickly.
Okay, I'm looking forward to that.
Definitely, sir. I'll send a mail to you immediately after this meeting.
Thank you.
Thank you, Mr. Kadre. Now, I can see Mr. Saxena, Director Operations of Vizag Steel Plant here, but I don't know. Saxena ji, can you hear me? Mr. Saxena, can you hear me? I can see Mr. Saxena there, but Ankit, can you see Mr. Saxena there? I can, as far as I see,
He's
there.
in the panel. He's in the panel. Yes.
He's on the panel, but Saxena ji, if you can hear us. Okay, I don't think. Okay, we'll move on to Tata Steel now. Mr. GRP Singh.
Good evening, sir. Good evening. Good evening.
Mr. GRP Singh is Head Quality Assurance Group and One Shared Services Technology Group at Tata Steel. So, Mr. Singh, what is your question?
Yes, sir. So, in fact, very recently I had good interaction with Mr. Mukherjee from Schaeffler. He was here. And Tata Steel is also working on Industry 4.0 in a big way. So we have established one asset monitoring diagnostic center, AMDC, and all critical equipments are being monitored online, and all the data is being brought to a central location. And our dream is that at one day, all equipment of Tata Steel will be centrally monitored. So that is our dream, and I'm sure FAG can always help us in this regard. I had one question. Actually, somehow we are not able to do condition monitoring of mill choke bearings, especially in long product mills, merchant mill, new bar mill, and wire rod mill, because every time they need to be fixed and taken out. So wired sensors are difficult to install. Also, it is very difficult to go near the bearing while mill is running. So obviously, through portable vibration analyzers also, we are not able to take vibration. So if FAG can give us a solution for condition monitoring of mill choke bearings, especially long product mills, so that will be a great thing.
Okay.
Yes, yeah, Mr. Kadam, please respond. Or Mr. Mukherjee.
Yeah, Mr. Singh, thank you for the your remembering our meeting. And just to from our portfolio, we have a product called ProLink. ProLink, that is an online condition monitoring tool, which is normally used for heavy duty equipment. So out of which your choke bearing would be also in that category for long product mills. But the problem that you have said, about mounting it and how to do it, that we will have a detailed discussion after this meeting. And I will also rope in our condition monitoring expert. We will have a discussion how we implement this. So would you be interested in that, ProLink?
Yes, sir. Yes, very much, very much.
Thank you so much. I think this is a wonderful opportunity for us, and we are very keen. Let me express our keenness to you.
Yeah.
So Monday, what I will do is, along with our expert, we will have a telecon and let us discuss this further.
Okay.
ProLink, I can assure you, ProLink is absolutely technically suitable for rolling mill, bearing chokes, and everything, heavy duty application. But the mounting part is something we need to discuss in detail. The inaccessibility that you're talking about. So we'll discuss it. I have noted it. I made a note of this.
Thank you, Mr. Singh, and thank you, Mr. Mukherjee, once again. Well, last but not the least, the gentleman who left the slot or sacrificed his slot should have a priority in asking not one, but at least two questions. When it comes to blaming the lubricant for non-performance of the bearing, how would Mr. Ajay Kumar Harinarayan take care of this?
I just
when
have
you
one
are blamed, and non-performance of the lubricant is blamed for failure of a bearing, how would you respond?
Just one comment, Mr. Ajay, before you ask the question. I think I'm sure you would not have any question. That depth that you have gone into without bearings in the discussion we had, you know more than us probably. Mr. Ajay is he knows a lot, and we had a lot of discussions. So anyway, this is just on the lighter side. Yeah.
So, Mr. Mukherjee, thank you for giving me an opportunity to ask a question. I really don't have a question because we have been working together. Whatever question comes, we have been always trying to sort it out. Mr. Negi, Mr. Mukherjee, I have known Mr. Mukherjee for the last 2 years only, but I know Mr. Negi, I know Mr. Gutsche, who came and installed a machine at our laboratory long time back. And I am in touch with Schaeffler for almost a period of 22 years now. So whatever queries come to us, I know I have a solution in hand. If I write a mail to them, they immediately respond. The only grouse my team has that they say, unless you write a mail, we don't get a response from anyone. So anyway, I am very happy to write an email to Mr. Gutsche first, then Mr. Reith is there, Mr. Reith at Schaeffler Technologies. So I don't really have a question. Whatever comes in there, we have been working together with Schaeffler, and we know whom to contact for what, and we are very interested in the 4.0 thing. We are also trying to offer such solutions. So maybe when we talk to you again, we'll probably be in touch how we can implement in a better way. Thank you so much.
Yeah, on a lighter vein, Ajay Kumar ji, I would like to mention that I always look forward to a day when you would not require a refurbishment center at all. When a bearing would become a lifetime bearing. When you go for a bearing, which would not, it will have, of course, condition-based monitoring, but it would not require a refurbishment. The bearing itself would last for a lifetime. These days when as I mentioned, the three big darling, SMS, Danieli, and Primetals, when they sell a rolling mill or they sell a caster or, they sell any equipment, whether it's an electric arc furnace or a blast furnace, primary thing which they talk of is a lifetime service. So which means you become, when Schaeffler goes and sells the bearing to Tata Steel or JSW or Vizag Steel Plant or SAIL, they don't just become a seller, they become a lifetime partner. So that's what we look forward to when it comes to Schaeffler's bonding with the steel industry in particular. Because
in fact, I will go a step further. I would, my dream is that equipments, when they come, they should come with sensors mounted on them, so that the bearing can tell you right away on a real-time basis what it is facing and how you can take corrective action, so that we can get the maximum life out of it. I know nothing has infinite life, but that is the dream which I have, which we should be working together towards.
Thank you, Ajay Kumar ji. Thank you so much. So if there is no other question, Mr. Kadam and Mr. Mukherjee, I would like to thank both of you for being such an important and busy day. The fact that you gave us so much of time. And my apologies for the slight delay, actually. One of the presentations went on for a little longer, and Mr. V.R. Sharma had a CII meeting this afternoon. That is why he joined a little late. So that we got a little delayed because of that. So my apologies for the delay, and special apologies to Ajay Kumar ji for holding you for such a long time. And we are basically almost 4 hours into the webinar. So what happens is, when we have such important discussions and important content together, it binds us together. At times, I remember the director of the previous chairman of SAIL, Mr. Anil Chaudhary, he was there in our webinar till 10 o'clock. From 4:30 till 10 o'clock, the chairman of SAIL, who ran 5 plants, was with us in a webinar. So that is an example of how interesting interactions become. This pandemic has taught us very important things. One is that to have more interactions together without putting in much of effort. You don't have to travel from one city to another to stay close to a customer or to your partner. We don't call customers anymore, we call partners in progress. So that's what this pandemic has taught us. So having said that, I would like to ask if any questions are there for Mr. Kadam and Mr. Mukherjee, or we'll move on to Mr. Ajay Kumar, who's been waiting for us for such a long time. Ajay Kumarji, are you still in office? Or
I'm still in office.
Perfect. So keeping your spouse unhappy till late evening is not a very good thing to do, but I keep doing that quite often. So
she's quite used to it. She's quite used to it.
Same here. So with that, we'll move on to, and thank you, Mr. Kadam and Mr. Mukherjee. We'll move on to Ankit, if you could take it forward. I'll just take a break for 10 minutes. And Mr. Ajay Kumar, please, the floor is all yours. And since you sacrifice so much of your time, you can take as much time as you want. I will not ring the bell. Please go ahead.
Okay, sir. I will. Can I share my presentation now?
Yeah, please go ahead. Please use the share screen option.
Is my presentation available, visible to everyone?
Yeah, absolutely. If you want, you can put it on full screen.
Is it on full screen now? Is it visible
to
everyone?
Perfect.
Okay. So, good evening, everyone. I would like to, sorry to keep you waiting, and it's my pleasure to be here and share some of our insights in our work, which we have been doing now. The situation is quite critical. We have been working on this area for quite some time, developing alternate grease chemistries for the steel industry. Just to give you an overview of this, what I'll be covering out here, I've got a few slides which will cover this aspect. I'll give you a complete overview of the global grease production. What do people use? What thickeners do they use? I will give you an overview of the Indian subcontinent points. Then I will go into the details of the lithium use, because lithium is the major issue here. It is being diverted towards other things which are more into vogue right now. So I'll go into those aspects and then look at the options, go into the pros and cons of the alternates, look at how it fits into the steel industry, and how we can fit the alternates into the steel industry, meeting the cost and the performance requirements. And I'll cover each of them in a few details, and then I will conclude my presentation. I will not take much time. I will just give you a brief overview. I want to give you a flavor of this subject so that you can also look at it. It's a major endeavor for the entire lubricant industry right now. We have been working. I know that many of my colleagues in the other companies which manufacture grease, not just in India, but across the world, are also working on the same aspect. This is the global grease production 2020. If you look at it, you will see the lion's share of the entire grease which is produced and used by all users, not just industrial, but even the automotive. It is lithium, and more lithium. You have got lithium-based greases, you have got lithium complex greases, and if you just look at the small percentages of the other alternates which are being used, maybe we hope that this will become bigger to shrink the stranglehold which lithium has over the entire industry. You will only find some of them which are just 7%, maybe 6% for polyurea, calcium sulfonate 4.04%. So these are very small percentages. Maybe these need to increase. So what we see here is, if you look at the Indian subcontinent grease production, you'll find that the figures become more skewed towards lithium. You have got 85% of the grease industry working only on the lithium-based greases or the lithium complex greases, whereas the other thickeners, they are not even having more than 5%. If you see other metallic, it is just 5% for all the other metallic ones. So you just have a very few, very little share of the other thickeners which are being used in the Indian grease industry. So our Indian grease industry is heavily dependent upon the lithium supply chains. Let us look at how the lithium trends go. You know, the pricing is very important for the grease industry. So if you look at it, the figures over the last 3 years, the pricing and the demand, it's going up and down. If you see a dip here, it was because of the pandemic, which led to the drop in the demand, not due to any other reasons. Another problem which lithium has is it is only the deposits for lithium are only located in a few countries. Chile, Australia, Argentina, and China have the major share of this, and it's a very small supplier market where the suppliers control most of the lithium supplies. 4 companies across the world, they look at they supply the complete lithium for the entire industry, not just grease, but for the other applications in there. So what you see here is in India, if you just look at, we don't have even a gram of lithium deposit in India, and we have to depend 100% upon the imports only. So the pricing affects us more. The volatility of the pricing, especially for a public sector company like us, if you have to guarantee supply by long-term agreements, that is not a thing which we can look at very easily. So we have to do something about this very clearly and very quickly about this. If you look at the lithium market trends and the share of the pie, the demand for lithium is going up very quickly. If you just look at this graph, it shows how the lithium demand has been going up and how it is expected to go up in the future. You will find that it is going at an annual growth rate of 21%. It is not on account of the grease industry, but it is on account of the battery or the glass and ceramic industry, majorly the battery industry, which from a share of 32% given here, it is expected to go up to nearly 60% because EVs, mobile phones, the devices, the batteries which will power them, they will require more and more, and we will face more disruption of supplies for the grease and lubricant industry. So you will also notice here that this battery and grease industry, the trends are very similar. They are very lithium dependent, and the product is very critical. The supply of lithium is very critical for maintaining the supply for both these industries. So we have to break this chain, break this stranglehold, and do something about it so that we can make a grease which can lubricate the bearings, add to the resilience of the steel industry, as was put up by an earlier speaker. We have to make them resilient against these aftershocks or non-availability of lithium or something which leads to the cost being so prohibitively expensive that we cannot bear it for making it cost effective for lubrication point of view. So if you look at the options which are available, if you look at just the factors, what governs the grease industry, the major aspect is the cost. The pricing of the greases, it's very important. Just to put it in a very benchmark kind of thing, if you take sodium grease, the price is 1. Lithium is about 2.3 times that. Lithium complex is 2.8 times that. But the concerning figure is this is going to increase to nearly 3. I think these figures are a bit old. It might have already crossed 3 by right now. And if you look at the high performance grades, you will find that these figures can go from 3 to 5 times the cost of 1.0 for the basic grease, which is the lithium with which the grease industry started. The factors which we have to look at is the raw material cost, the availability, the ease for manufacturing, and how they can conform to the conformity. Unfortunately, lithium is the only grease which meets the performance conformity and also the cost at the present moment. And so it is so we are so heavily dependent upon that. If you look at the lithium alternates, I have tried to do a survey out here. Like if you decide to go for sodium, you cannot use it where shearing happens or water is present. Rusting may occur in this case. If you go for calcium, you will find that although it is abundant, it is not easy to manufacture. And also you cannot make a grease which can go beyond a drop point of more than 100, 150 or so. So it is ruled out unless you modify the product and make it suitable there. Aluminium has toxic inputs. Also, we have to import the inputs for this aluminium complex grease. If you look at calcium sulfonate, Tata Steel used to say this is the grease of choice for us. But unfortunately, you have to spend more money for this. You have to use more soap to form the same grease. Also, the major issue with this is you cannot mix it with other greases. The incompatibility is a major factor which can affect these things. If you look at polyurea, the major issue which comes from this point of view is the toxic inputs. You have to have specialized manufacturing process, maintaining all safeguards. Also, the incompatibility is something which can probably play havoc. If you go resort to the old school of thought and go for clay-based greases, unfortunately, it will not work where the shearing is high, the speeds are high. So you'll have to look at something else or maybe modify it to suit the requirements. If you look at coming to the steel plant greases, steel making and the steel industry has a variety of diverse processes. You have iron making, steel making, rolling, bearings, auxiliary, you have mining in there. So a variety of greases are used. Unfortunately, lithium meets most of these requirements, and so it is the product of choice for them. The extreme pressure, the fire resistance, high temperature, water resistance, open gear, wire rope, you are forced to use lithium generally. The flowability for a centralized system also, lithium takes care very well compared to the other things. But there is hope that if you work towards developing a grease which can alternate, which may not be the one source kind of option, you can probably go for something which can fit the bill and meet these demanding requirements of the steel industry, where the base oil viscosity can range from 150 to 1000. The EP characteristics, the 4-ball weld load can range from 200 to 800. And also the incorporation of the solid lubricants, which may be needed for slow moving equipments and lower friction. You'll also need to find a grease which can use these solid lubricants and incorporate them, get a perfect homogeneity in there. It will probably be something we need to work on. We have been fortunately, we were sensitized about this issue from a very long time. So we have been working, and I will share some of the things which we have already worked on and developed. Some of these points were already covered by the speaker from Visakhapatnam Steel Plant and from Bhilai Steel Plant, where they mentioned our product grades. I was so happy to note that. So they were happy to see that the alternates are becoming the product of choice for certain application, but we need to expand the domain for the product of choice to make the alternates the product of choice instead of lithium in this case. If you look at lithium, lithium possesses excellent mechanical stability, corrosion, water resistance, and it is suitable for the centralized lubrication systems. If you do a complexing with lithium, you'll probably get the high temperature performance, low oil bleed, and very good shear stability. So it is the product of choice. But if you look at the other ones, there are some characteristic attributes which can be modified, and probably we can make them suitable for the application area of the steel plant where these diverse requirements may need to be met. So we can do that, and we have done it for some of the greases, and taking into account the performance, the pricing, and the compatibility, we should be able to get to a solution. I'll cover that in the subsequent slides, in the coming slides. So what we considered was, these were some of the options which we considered: calcium complex, Then sulfonate, the existing one, which was the product for choice for Tata Steel, Mr. C. Mishra used to tell us this is one product I will vouch for any time. But unfortunately, it used a lot of sulfonate. We needed to modify it so that we can, without sacrificing on any of the properties, we can make the grease with a low sulfonate, reduce the price, and make it acceptable. We have looked at blending calcium with lithium, going to the extent of increasing calcium to over 50% and reducing lithium to a very minimal one so that the product film, the reactivity and the film formation is not sacrificed. Synthetic polyurea and polymer are also the other things. Without compromising on any of the performance attributes, we try to reduce the dependence on the costly lithium in use right now. Coming to the first one, which is the calcium complex grease, we overcame the problems of the manufacturing in this case. We have developed a calcium-based grease which can give a performance of the level of lithium complex grease. We can make different grades, grade 2, grade 1, and it can be a suitable alternate. And we also find that this one does not have any compatibility issues with the existing grades in use. So it can give us the tribological life. It has been established in several steel plants. One of the products was mentioned in the presentation by the Visakhapatnam steel plant, where they found it to be very good for working with the water application. So this is one encouraging sign for us. Coming to the low sulfonate content grease, the usual sulfonate content can range from 60 to 80%, which is very, very high and makes the product very costly because many of these inputs are imported. So what we have done is we have developed a product which gives the same performance with 20 to 30% only sulfonate content. And it is giving us the same level of performance when we check the tribological testing. We have done the storage stability, we have checked the compatibility, it is able to meet the requirements. And so that is one thing which is encouraging, and you will see more grades from our stable work in this area. Coming to the mixed base grease, the calcium lithium, what we found was if we just had calcium, there were some reactivity issues with the various fatty acids. So what we did was we incorporated some lithium to get the balance, and we achieved the same indicators as a simple lithium complex or lithium base grease. We subjected it to a storage stability, the tribological testing, and we are able to make a lithium grease mixing with a calcium content of more than 50%, thereby reducing the cost and reducing our dependence on lithium. Then what we also looked at was polyurea. Polyurea was generally a product which was only a Japanese origin one. I have seen this product long time back, maybe 20 years back in Visakhapatnam steel plant. They used to sell this product, but Japanese are very keen about it. In our domain, what we found was it was very difficult to manufacture because of the toxicity issues and also issues of making a specialized production unit. So what we did was we modified the process. We have now generated a synthetic ester-based polyurea grease, which is able to meet the requirements of a heavy-duty electrical motor, something in the range of 500 to 1000, maybe much higher, something which is suitable for a steel plant application. We were encouraged by the good life. We were encouraged by the life even at high temperature. So it is good grease which can meet the requirements of the high temperature application and also give us the long life in this case. We use one of the equipments which Schaeffler gives internationally. So we established the life using that internationally benchmarked equipment. So that is something which helps us to check whether we are meeting our target. And now after doing a trial in one of the applications, we found that it got a life of more than 2,500 hours, which is quite significant compared to a normal lithium complex grease, which had a much lower life in this case. Coming to the last one, which was a polymer grease, we found that there was an application where the speeds were very important. It was a high-speed bearing application. We found that none of the greases could meet the requirements in there. There were problems of bleeding. There were problems of throw-off. So all those things we have reduced by using a polymer-based grease, by changing the process for making this grease. and it is now field established, and we are able to use it very significantly. We can offer it for some of the high-speed applications which plague the steel industry and maybe replace some of the lithium-based greases. So this is my last slide. Just to sum up, lithium prices are continuously increasing. We expect that this will not change in the near future. Maybe more and more of lithium will be diverted towards the battery and for the EVs and the mobile devices. Also, the reserves, which are only there in a few countries, they are coming down quickly. And we, in the grease industry, should really work on reducing our dependence on this to maintain the price to performance ratio. And especially for a challenging application like a steel plant, we should be able to overcome any of the challenges which they pose to us by looking at the alternates which we have developed. These are some of the alternates which I just covered in the presentation. And we will continue to work. We'll continue to work on other metallic and non-metallic soaps, which can also help us in reducing our dependence and meeting the requirements of the end customer and make the steel industry as resilient as ever. Thank you so much for your time. And I hope if there are any questions, please let me know. I'll be happy to answer them.
Thank you so much, Ajay Kumar ji. Thank you so much. I thought you will take a little more liberty of the timing flexibility, which I requested you to take, but you did not opt to choose for the same, and you finished faster than, let's say, what I expected.
No, sometimes I go for the what the end user undergoes. I look at those aspects, and I decided let me go into a high-speed mode and maybe meet their performance requirements and their requirements so that no one is waiting at home for them also. So I thought, let me just cover them quickly and do that. But I will be happy to answer any questions in this case.
Yeah, Ankit, is there any question in the Q&A section?
No new questions in Q&A.
So any questions for Mr. Ajay Kumar? Because, he touched on subjects like increasing prices for lithium, which makes the lithium complex greases more expensive. And this afternoon, when Mr. V.R. Sharma, Managing Director of JSPL, he mentioned very clearly that we squeeze the manufacturers to a great extent by extracting maximum price leverage from them. And by virtue of that, we all know today the grease manufacturers, the lubricant manufacturers, they have a very hairline margin. With the number of players, I think, Ajay Kumar ji, today, if you calculate the small and big players together, it will be 70 to 80 players.
Yeah. There are a lot of players in the unorganized sector. And
yes.
We are concerned about them because they don't guarantee much. We have to look at we should look at offering guarantees that we will guarantee the performance, give you the kind of thing. We are there with you. That is the thing we look at. And unfortunately, the industry has become very difficult to manage, but we are managing with our strength of the technical aspects and other things in there.
Yeah, then again, emotionally, I get little charged up when this issue comes up, because my father was always responsible for the formulation part. And, my father, Manoranjan Mukherjee, late Manoranjan Mukherjee, who's not there in this world anymore. But, our family discussion, even at dinner table, would center around issues like the base oil prices have gone up so much. What do I do? How do I control additive cost? This is not in my control. So these days, one of my friends, Sanjeev Kaul, who's now the managing director of Lubrication India, a very good friend of mine. So I wanted to invite him. He said, lube is not my subject anymore, so I would like to stay out of it. I wanted to invite him only for one reason, because the additive cost is something, when you make biryani at home, if the cost of biryani spices go up, how would you make the biryani? So that is something. And again, the additive is one part which most of it, I would say, even today, to a great extent, is import dependent.
Maybe what you can do is you can ask Mr. Paul to start making pre-formed biryani for you. Complete solution.
Yeah, this is what, in fact, bothers me as well today when I see that the manufacturers, their margins are getting eroded, and if you calculate in the IOC, the total loop business may not be even 4 or 5% of your total business.
No,
I
it
don't
is
know the
not.
exact percentage, but obviously it's a very small percentage of your total business.
No,
So
it is
obviously,
small. It is small, but we believe in offering complete solutions, right from fuel, lube, and any other of the alternates now. So we believe in our philosophy has always been like that. Make the customer completely happy, not just by supplying one product and being happy about it.
exactly. In fact, one of the complaints earlier, I was used to every NLGI conference I used to attend. So one of the complaints I used to hear from so-called private producers is that NLGI is controlled by IOC. So this is a complaint which some of the private players used to. I'm not naming them, but this is one complaint they used to do. But I think the fact remains that because it is under the control of IOC, if at all it is, we have been able to deliver R&D at a nominal cost.
In fact, I'd like to add here, NLGI is housed by IOC. Tribology Society of India, for which I am the secretary, is housed by IOC. And many times I get to hear IOC is now doing this in this society. So I said, no, it is not IOC. It is a different hat. I work for the society and I am facilitating that aspect. Our management is facilitating this aspect because they want the thing should flourish, not die down quickly.
Exactly. And, for years, if you see, your colleagues, whether it is Dr. Ramkumar, whether it is Mr. Deepak Saxena, all of them, they have given their life for NLGI. They have given their life like you're not getting salary by virtue of being the secretary of TSI. It is a voluntary work that you are doing for NLGI India chapter at TSI, all these institutions who have contributed a lot towards this segment, which is, so to say, not a huge capital intensive segment, but somewhere where the promotion of the industry has to be done by an institution, which so successfully IOC R&D, particularly I'm naming IOC R&D because that is where the majority of contribution has come from. And I remember, in fact, Dr. Ramkumar, when he was addressing the audience, he mentioned specifically about the Indian steel industry, because the steel industry has been a great partner in progress for, let's say, the entire lubricant industry together. My friends from, whether it is from ExxonMobil, whether it is from Castrol, I keep telling everyone that this is one segment which has kept the so-called the mills running. So without the help of the grease and lubricant industry, GNL industry, the steel industry would not be able to even look at savings. This afternoon when the presentation from RNL was there, mentioned that today perhaps per ton of steel, 250 to 300 ml of say 300 grams of lubricants are being used. At one point of time, I remember it was more than 1 kg. So gradually, what has happened is the lube consumption over the years has come down drastically, especially with the high performance lubes. One thing, Ajay Kumar, I think, which you did not highlight so much today was the high performance lubes and synthetic lubes.
I did not do those so because my prerogative was I did not want to exceed the time limit, and maybe on some other day we can do that. I would love to give a presentation on the objectives of the carbon neutrality and other aspects too from the tribology point of view. Something like that we can do in the future if you permit us.
So just give me 1 month's time, Ajay Kumar ji. Let me formulate a plan together where TSI, which you are the secretary, TSI and perhaps also NLGI, we can pull along with our magazine. We could have a series of workshops, 1 day, 2 day workshops, or even at least a day's webinar where we will focus only on high performance and let's say synthetic lubricants for the steel industry. Because there are two industries which I am directly involved. One is mining, the other is steel. So these two industries, though they have synergy together, but both of these industries they need the support of your industry.
In fact, I was very enthused by the comment by Mr. Kadam today that the energy spent in making the bearing, it adds to the carbon footprint. So, in fact, if you look at the Princeton wedges, which talks about the efficiency improvements and the cost of making something to be added to the carbon footprint, that is something which needs to be stressed upon in this world, besides the normal products which you are planning to cover in there, which we can do very well out here.
Early next week, I will get in touch with you so that we can formulate a time and date together, where we could take this together, and let us have a series together, because this is, as I mentioned, this is a very passionate subject for me, and it gives me a big amount of emotional satisfaction when I get to work with this industry and promote the lubricant and grease industry in India. So thank you so much. And we have your colleague, Mr. S.K. Biswas, BGM Technical Services HO at IOC, who's going to cover perhaps the issues which you have intentionally skipped. So thank you once again, Ajay Kumarji. And if you are still not going home, please stay with us for a little while to hear what JSW and
I will probably
and even
join
at home you can join. Even
no,
if
I
you
will
go
join
home,
on the way. I'll join on the way. I don't worry.
Yeah. You can join from your mobile on the way, and when you reach home also you can join. There is no problem.
I'll do that. It will be a pleasure to join.
Thank you so much, Ajay Kumarji. Thank you so much from the core of my heart. So with that, we'll move on to Mr. S.K. Biswas, DGM TS HO at IOC Limited. Mr. Biswas, a warm welcome to you. So I think Mr. Ajay Kumar has already done justice to the subject, but you are more on,
yes.
I would say, a direct day-to-day person who is in charge of the marketing related areas also. So without technical services, the marketing of ISC loops would fail. So you will have to do justice on
the USP. Obviously, people have waited for such a long time. So I'll also do the justice. No issue.
Thank you, Mr. Biswas. Thank you so much. And my apologies for the wait you had to do. And if you see the comments, Ajay Kumarji, you'll see many compliments are coming in for your great presentation. If you see Q&A section, the people are thanking you for your presentation. So over to you, Mr. Biswas.
Yeah, good evening, everybody. Actually, this presentation, I'll be just highlighting the major grades that energy efficient grades or other grades. Actually, see, I was listening whatever our main customers has pointed out. See, it's really a good thing that our product is really recognized and used by the customer. See, in this competitive business, particularly steel industry, we are having all grades for continuous improvement, technical services, and always supporting the customer has been a good thing from Indian Oil. So I am in head office Mumbai. We are doing this type of, we are monitoring this technical services. So we are having all grades of lubricant for the steel industry. It is hydraulic oil, gear oil, any other lubricants, but how it has improved from one step to other steps. The old lubricant, then higher, slight higher, then suppose gear oil, mesh SP series, XP series, then gold series, then synthetic. So this transformation is required, I think, in steel industry. So we are having all those type of equipment. So I'll be highlighting some of the grades. So it will basically whatever new equipment is coming in India, particularly in steel units. So we do not have that approval. So there is a issue. So to get the to introduce our product in steel industry. In that case, See, whatever we normally consult with our lubrication cell in all steel units, then we define, and whenever it is not meeting or they are not satisfied, then it goes to our R&D. You know that we are having a biggest R&D in Asia, and this R&D center is capable of making any type of lubricant for any type of industry, particularly for steel sector. Whatever challenge is coming, you see in greases, in case of any other oils. So we are time to time meeting the requirement of the steel sector. So that is one more thing. So I'll share my presentation. I think it's visible.
Yes, it is visible. Yeah.
It is visible. So we are having all type of lubricants, but I'll be just is it full screen is there, but I'll be highlighting only these 4 types of lubricants where we are still trying to introduce these oils, particularly these NTM oils in major its steel industries. So if you see from this, the production of steel has gone slowly to a higher level, and accordingly, bar and rod mills, you can see it has also this bar and rod mill also increased. Production has increased. So total share, if you see, so it has gone from 37%. Then little bit in 16, 17, there was a little bit down. Then 18, 19, 38%, and then again April, December 19, it has gone. And I think due to this pandemic, there are some issues, but it has picked up now. So it slowly it is increasing. So there is a this bar and rod mill is coming up because it is having a good profit margin. So steel sector is going. So we want to introduce our oil in that sector. We are having this oil. This oil, actually this particular oil, NTM oil, so it requires a specific type of properties. If you see this this schematic diagram, you can see this flow chart, how it is going and how, and if you see from this side, how this different type of transformation has taken place over the time for this mill. So this, when we see this, we design this oil, or we go to the industry, say main problem is basically cooling water, controlling cooling water. So this, if some industries, they are using DM water, some industries they are not using DM water. So normally if this cooling system is not properly maintained, so there are issues which is coming basically in the oil. So this oil and water, basically they are giving protection to the seals. So due to this operational activity, so there are breakage in seal. So due to seal breakage, this water oil mixing is there. So whenever water is going, due to in it is also carrying some sort this thing iron dust. So there are issues if this oil is if this water is retained in the system for a longer time. It basically increases the problem. So main issue is that we need to remove water immediately from the system. And even dynamic demulsibility property has to be very good in the oil, so that in during use also there should be instant separation. So if this oil is retaining the system, so there will be bacterial growth, and due to bacterial growth, it will choke the filter. So filterability is one of the issue that is required for the oil. Good oxidation Stability is required because this oil is coming from the zone of high temperature steel, so it is carrying temperature, though they are maintaining cooling system. So this oil is basically getting dirty because of this ferrous particles, water, and water, if it is coming, if it is not treated, then it is also carrying different type of impurities that is going and sticking to the filter. So filter life is one of the issue. So if you are using good type of filtration system, this oil system, and then filtration system, then this issue can be reduced. One of the major consumption parameter is filter. So if filter consumption increases, if filter life can be increased, so their filter consumption will reduce. As a result, there will be overall benefit. So this particular sector is having a good type of profitability. So normally big industry, they are not, though they are purchasing the oil at a very high cost, but they are not ready to basically go for the trial. We have conducted trial. We are having this oil from the beginning, but there has been a drastic transformation, drastic change. Whatever oil in the earlier session, I think this RINL representative Mr. Mohanty was just mentioning that they have changed all the oil except this one, because it happened in 1994. After that, there has been a drastic change. This oil has been developed in a different way. Now this oil is having all the required property as compared to best oil available in the market, OMC oil in the market. So this oil can be used this oil can be compared with anybody, any oil, and just this grade name of our new oil is Servo EP100 Plus. It is basically used for lubrication of NTM system, film bearing, and inside the blocks. Internationally, normally these blocks are supplied by Primetals, Morgan. There are some few earlier Morgan Stanley, Danelli, SMS, they are basically supplying, but earlier they have given a few approvals, but nowadays they are not giving the approval. It is only Morgan specification. Whatever oil we have developed, it is fully meeting Morgan specification. We are having all required approval from related sectors. In Indian players, we are having normally a small new field engineers. They are basically locally manufactured. One or two other player also there. They don't. They are basically using our oil, and their performance is also very good. This is a non-EP type of oil and group 2 base oil, basically having excellent demulsibility as compared to available commercial oil. Higher connective viscosity, it is because commercial oils is having a little bit low connective viscosity at 40 degree, maybe at 90 or nearby 90, but ours case it is around 100. This viscosity index also, viscosity index in our case slightly higher viscosity index as compared to the oil available, commercial oil available in the market. It is meeting all Morgan USA requirement and is approved by Danelli. This oil requires also this for dynamic demulsibility properties. We have got the oil tested from Clark's Lab USA, and they have approved this grade. Now, if you see the properties, it's you can see there are demulsibility, water solubility, air release value, 4 voltage, RPBOT. All those things are for. In case of Morgan, it is if you say it is 140, but in our oil we have seen it is maintained above 250 or around 250. Even after operating or more than 2 years. So we are having all our, you can from this also, what is this separability. So there also everything it is meeting as compared to our oil is having all required properties. Now this oil has been trialed from initially from 2015 for 2-3 years. After that, we wanted to compare the data with OMC oil, obviously the best one. Then we didn't have the data, so we again went for this comparing the data. So we charge our oil for 10 months and we generate data. Then we charge this thing OMC oil for another 10 months in the same mill to see the result. So after comparing this both the oils in same mill, in same condition, same operative condition, so we found that oil performance feature is all parameters are in control limits, both the cases. Operational parameter, pressure, pump pressure, line temperature, bearing temperature, current, etc. That are being all those data that are being maintained by the steel industry. As we compare both the data, and it's normal. Average bearing temperature of cassette, it is also normal in both the cases. Production, there was no deviation, no problem. It was also normal. Oil top up, it was similar as compared to best oil, OMC oil. Water ingress, ingression, it was also varying from 0.1 to more than 2% in both the cases with similar condition. Then filter life. So we earlier, before the trial, it was we came to know that the life of filter with OMC filter is maybe 2-3 times more whatever we got. But when really this we tried and we generate the data, so it was there was no difference. So we got the this thing letter from our Bhilai steel plant, and then private sector also having many this type of credentials. Now another sector is hot rolling oil. In steel industry, this hot rolling oil is normally is one sector that is very demanding and being used, and this is also important. Most of the cases important. Now we are having two types of hot rolling oil. One is this thing rolling oil, hot rolling and cold rolling. Now hot rolling oil normally this ager and then other section this all many steel plants they are using only water. So these are on this particular sector there is a lot of potential of savings. So Indian Oil R&D from we developed this type of rolling oil that can be used with water and give substantial savings. So in this case, we tried our product. Suppose we are having Servosteral H2, Servosteral H3. So Servosteral H2 basically slab flat rolling, Bokaro and Raurkela we have tried, and then Servosteral H3. Basically, this H2 also we earlier we used to use in this oil in rail mill at Bhilai steel plant. Now we have upgraded. Now Servosteral H3. This is also being used in Jindal Jaspur. Now we are going to this thing try this grade at Jindal Hisar with improved formulation. Now Servosteral H4. It is also basically being used in rail mill Bhilai. Servosteral S5. It is also basically ager or lubrication. In ager, normally there were no lubricants earlier. So by using this sterile S5, there has been a substantial savings for JSW Billari Bokaro. So we are going ahead with this to other industries where this type of benefit can be availed. The service trail A6, this is also being used by JSW Billari. We are offering A6 are earlier used in other units also for backup roles, slab. Now, this is actually all these grades are offered as per the specific condition. It is basically a specific condition of the mill. All mills are different in some parameters. So all these grades are also developed accordingly to, it is basically customer specific, mill specific. So every this same oil may not be used for all industries. We need to make slight changes in the formulation in the properties so that this oil can be offered and to get the best benefit. Now service trail A7, this is basically being offered and being used in URM, Universal Rail Mill and Bilai. It is the best mill, best technology, but there also they didn't recommend any lubricant for this particular mill. But from the experience of Village Steel Plant, they basically wanted oil to be developed by Indian Oil. So we have developed this oil, and there has been a substantial savings in terms of life of roll, all oil consumption, campaign, all those things. Then service trail H8 has also been developed and is planned to be trial as JSW Billari. So if you see what has been the changes. So if you see all those grade has given different type of benefit, and overall everybody is looking for the savings. How saving is coming? It is coming from by improvement of roll life, by improvement of campaign, by improvement of electrical power consumption. So if we calculate all those things, we are having previous data for all those things. After using the oil, they have generated data, and by comparing that, it has been seen that there has been savings of around 25 to 30% overall savings by using this grade. So through this forum, we like to convey to other major steel units so that they can try this product to get the benefit, because it is due to a new type of innovation, rather where OEMs are not recommending oils, but by using this oil you are getting the benefit. This is basically dispersion type of rolling oil without any animal fat, controlled by this is controlled separation of oil for optimal lubrication, excellent spreading characteristic, improve wear and tear. All those things are there. Safe, high flash point, very good thermal and oxidation stability, high film strength. All those properties are incorporated, are basically required for this oil, and this oil has been developed according to the requirement. Now, these are the credentials. Basically, we have got a credential from Rourkela Steel Plant, Bokaro Steel Plant, Jinda Steel Plant, then some other units also. Now, these are recently, basically 2020. This is the latest one. We have trial this our new series is 5, then hot strip Bokaro, and they have basically got. You can see this type of achievement. They have got percentage increase in average campaign is 23.59%, reduction in average specific oil consumption 22.54%, and savings of 6 to 7% in electrical power consumption. So there has been an overall saving of around 5 crores. So there are the potentials where others can this can be used and get the benefit. So on the other hand, whatever this oil we are offering, we are also offering the system along with in combination with oil, where we can also provide a system if the users agrees. Now we are having these are the properties of all the oils we can see. So all oils have different type of kinematic viscosities, different type of densities, different type of this thing acid numbers. So this proves that all oils are having different type of requirement for the industries. So it has been developed accordingly. Now we are also having this neat rolling oils, neat cold rolling oils. So this oil basically it was developed for Jindal Hisar, and this Servosteral 22 gel is basically used by Jindal, and this other version only 22 that we are offering to other users. We are having some customers, those who are using 22, but their these properties are different. It is because, as I said, all units, they're all steel mills are having their specific this thing requirement of oils, and it is customized only. Now we are also having soluble cold rolling oils. It is basically semi-scented type of series. So different type of oils we are having. We are having C5. We are having different type of oil, but out of that, basically the Servosteral C5, Servosteral SS C6, SSC28. So these are the oils that are being mainly used by different customers. So you can see that saponification value is varying. All other property, viscosity also, there are different viscosity index also high. Flash point, then this thing, or other flexure load, tan values is varying depending on the requirement of this thing mill. We are also having a different type of rash preventive oil. See, we are having many type of rash preventive oil, but these oils we have developed only to replace this thing solvent-based rash preventive oils. So there are hazard, this thing safety hazard. There are environmental hazard. So our company decided not to sell any RP oil on solvent base, which are made on by using solvent. So these are the oil. This is not solvent based. This is oil based only, and having very high flash point. It is more than 100. So this is not effective the environment. Then this emission points, if you see, so that is also, it is good, green and environment friendly. It is there are this it is from hazard point, fire hazard point, it is safe. We can use those places where there is a chance of basically whatever what rolling is coming, or it is in hot form only. So if we use this solvent based oil, so there is a risk of catching fire. So accordingly, this for all those areas this can be used, and it is also meeting all other requirement. This humidity cabinet test, salt spray test, whatever is the requirement for particular application, it is also meeting all those things. So with this, we are also having this fire resistant hydraulic oil. We are this thing having another grades also, basically these are also newly developed grade, that is Servo RP 180 ES and Servo RP 190 ES. Basically this is electrostatically spraying applications, and it is used for particularly these are developed for POSCO, and now it has met their requirement, and we are about to supply this grade. All specification is already there. Kinematic viscosity, it is high 70 to 75, and RP 190, yes, it is 20 to 25. This thing CST at 40 degree. Flash point is more than 200 in both the cases. Film thickness 5.5 to 6, and this for this case 3 to 3.5. Coverage is more than 150 meters per liter, and in this case it is more than 300. Water displacement test, both are passing. Humidity cabinet test more than 600 hours. It is also this RP 190S, it is more than 300 hours. Salt spray portion test 75 to 80, and for 190S it is 30 to 35. Acid atmosphere portion test, it is 100 to 120 hours, and it is 240 to 260 hours. Now we are having this fire resistant hydraulic oil. Sorry. Now, these are the oils that is basically required for steel or aluminum or any other industries where there are this thing furnaces and hydraulic oils are running, and there is a chance of catching fire due to leakage of oil, and if this molten metal come across with the oil, and there is a chance of catching fire. So to save any fire incident, these oils are basically recommended. Already many industries are using, steel industry are using different type of this type of hydraulic oils, basically HFA, HFB. HFA is having a more than 80% water. HFB is having more than 45% of water. Now we are having HFC. This is basically water polymer in water water glycol. Water is around 38 to 45%, and then HFDR, it is fully this thing synthetic fluid, then it does not contain any water. And then other HFD series is basically polyester, and depending on this requirement, these grades are used. Particularly this WG series are used by steel industries. Then this servo fires WG40 68 are very common, and it is this HFB 68 is also approved by DGMS Dhanbad. And servo system HFD 46 years and 68 years. These are the very common grades are being used in different across different sector, not only steel industry, but other sector also, mining sector, then this aluminum sector and other sector. With this, I think I finished my small presentation. Thank you very much. Mr. Mukherjee.
Yeah, Mr. Biswas, thank you so much
Yeah.
for giving a product-oriented, very good presentation. I would say whatever was left out, you have covered the rest on the market approach. So this is what customer education is all about. So you have educated your potential customers today on each and every relevant product, both traditional as well as synthetic lubes. And you have done perfect justice to the subject. As you said, you waited for so long. I think by waiting for so long, you could use the thought process to deliver the perfect education to a customer. Because
it's basically a overview. So for each and every grade, we are having details, this thing, technical details or references for those cases. Actually, whenever somebody is asking something, so we go in details. Just I touched upon all those things, so that what are there in our kitty, particularly this NTM oil, this this is one sector where we are trying to introduce. Actually, Mr. Mohant is not there. I wanted to actually talk to him on this issue. Others are also, but see, this is under this Atmanirbhar Bharat government of India initiative. So we are trying to replace the grade. Even in our refineries also, wherever we get any imported grades are there, we try to replace the grade by developing equivalent similar grade. So it is saving our foreign exchange. It is saving. It is basically giving us this Atmanirbhar whatever it's given by our government. So we are working on that, and we are trying to convince all our users. So this confidence, at least see from the morning session, you could understand, people are happy with whatever product we are offering, but they need to have confidence of new series also. Some grades, they have, most of the grades they have accepted, but some grades they are still hesitating. But I think they need to have confidence on Indian Oil for those grades also. Particularly this servo steel EP100 plus, we are confident, so nothing will happen. Actually, Mr. Mukherjee, when we started this trial, there was so many assumptions. There will be loss of 200 crore, so many crores, mill will be closed for a long time. So those assumptions has been actually, though they have not used this particular grade for, they have not trial because of certain impact. So this is there, but somebody, the 16th sector has to come forward, and they have, we are here to give the full confidence that nothing will happen, and they will save a lot of money for themselves and for the country.
Thank you so much, Mr. Biswas. Absolutely, absolutely. Now, after your presentation, Mr. Biswas, I would just like to ask if there is any question. Otherwise, we will move to two of your very important customers. One is JSW and other is Tata Steel. Two of very important customers. So, any questions for Mr. Biswas, or we'll move on to Mr. VSN Murthy, Senior Vice President Maintenance at Vijayanagar JSW Steel, followed by Mr. GRP Singh, Head Quality Assurance Group and One Shared Services Technology Group at Tata Steel. So back to back, two of your most important customers,
exactly,
and two of your most important partners, I would say. So any questions? If Mr. Biswas, if you could just stop sharing your screen so that I could see if anyone. Okay. So I assume his presentation, Mr. Biswas' presentation was so comprehensive that there is no scope for any questions. Thank you, Mr. Biswas, and please listen to two of your customers who are waiting to see what you can deliver in terms of their cost savings. So when Mr. Murthy goes and tells Sajanji, this is what I have saved from maintenance cost. Whenever I have interviewed Sajanji, one thing he keeps saying, that is, we have a very aggressive DNA, which means not just aggressive DNA in terms of reaching out to customers, but also to make sure JSW is the cheapest cost steel producer, not just in India, but one among the world. So to make JSW a lowest cost steel producer, IOC and other players like you have a very big role to play in reducing the cost, in reducing the carbon footprint, which again is a subject close to Sajanji's heart. In fact, whenever I interact with Mr. Murugan, or I interact with Dr. Noal, I keep asking, what is it that helps JSW in being what it is today? By next year, you will see JSW as the largest steel producer in India. So it will overtake SAIL. It will become the #1 steel producer in the world. Already, the last milestone which has been achieved is 5 million ton at Dolvi. So that's a great achievement for JSW, achieving 5 million tons. And the company is targeting to be a producer of 38.5 million tons in a few years from now. And so with that, JSW, the largest potential steel producer in India and one among the top producers in the world. JSW R&D facility is one of the best that you have in among the steel producers today. See, SAIL has a legacy of its own by having its own RDCIs for years. Now, Sajanji, in spite of knowing that for R&D you don't get results overnight, it takes time. He has invested in R&D. He wants to make sure that JSW is among the top steel producers in the world. And as you know, Mr. Sajan Jindal is now the head of the president of World Steel Association. He is now heading the World Steel Association for this year. So a great achievement by an Indian steel producer. So with that, I'll move on to Mr. VSN Murthy, Senior Vice President, Maintenance at Vijayanagar JSW Steel. Over to you, Mr. Murthy, followed by Mr. GRP Singh of Tata Steel. So back to back, JSW, Tata Steel.
Okay, thank
Over
you,
to you, Mr. Murthy.
Yeah, thank you. Mr. Ankit, I have sent the presentation. Can you help me in sharing it?
Yes, just give me a moment.
And Mr. Murthy, please also convey my special thanks to my Dada Pravada.
Yeah, sure.
Yeah,
Sure.
he is my Dada in real sense of the term. So
Okay.
in Bengali, in Bengali, Dada is considered the head of the family.
Yeah, he is Dada to me also.
Yeah. So Pravada, I must thank because he is the one who said that I'll give you the best possible person I know who will do justice to the subject. So
Sure.
my special thanks to you, Murthy Sahab. And
Sure.
next time I'm there in Vijayanagar, I'll come to enjoy a cup of tea with you.
Certainly.
Because now, Dr. Nawal, since he is in Bombay, I have to look for a time when he is coming. So I will tag along Dr. Nawal's plan because Dr. Nawal is spending more time in Dolvi now. Every week he's going to Dolvi.
Yeah,
and he's
now it's
spending-
commissioned.
Now it's commissioned. So his job is now much easier.
Yeah.
Yeah. So over to you, Murthy Sahab.
Yeah.
Ankit, please share the presentation.
Yeah, I'm actually looking for the presentation. I am not able to find it yet.
Or can you share the screen? I have it in my desktop.
Oh, if you have it in your desktop, then you can share the screen. You can press the share screen button.
If you see the green button,
Yeah.
share content, just click on the share content. First, you have to open the presentation. First open the presentation, then go to the.
Now this is visible?
Yes.
Absolutely.
Okay. So good evening to everybody. Now the flow of my presentation is to have an overview on the JSW group, followed by the Vijayanagar process schematic flow and the maintenance systems at Vijayanagar and the condition monitoring practices we do at Vijayanagar. I have a few case studies in steel making for today's presentation, followed by the lubrication system performance indicators. So JSW Group is a multi-billion-dollar conglomerate, and we are present in India, USA, South America, Italy, Africa, and other parts. And we have verticals in steel, energy, cement, infrastructure, paints, and other ventures. So this is the current capacity of Vijayanagar Works is 12 million, and we will be ramping up to 23 million by 2025. This is for Vijayanagar. And we are one of the fastest growing company. And this is the schematic, process schematic at Vijayanagar Works. So we have the raw material of iron ore, coke, coal, fluxes. We have ore beneficiation plants because this location majorly works with iron ore fines of low Fe. And we have pellet making, we have coke making, coke ovens, then the iron making units where we have Corex plants along with blast furnace. We also have a DRA plant, and we have 3 steel melt shops, followed by hot strip mills, long products like wire rod mills and bar mills, and also cold rolling mills. And that's the total product portfolio at Vijayanagar. Now the next is I would like to explain the maintenance system which is being practiced at Vijayanagar. So basically we have 2 systems here. One is a shop maintenance system, and the other one is the common facilities which are being done by a centralized maintenance system. So the shop maintenance system does the preventive maintenance. It's the cleaning, lubrication, inspection, tightness and adjustment of the equipments. Now the common facilities, like we have mobile equipments here, the EOT cranes, the AC ventilation systems, the condition and monitoring of rotary equipments, all these are supported by the central maintenance team. So we have the departments does all these spares planning and procurement, and the departments make the maintenance plans for time-based inspections, preventive maintenance, shutdown maintenance, and all other plannings. So we have a roll shop maintenance for the mills, which is done by a third-party services. The shop maintenance also take care of the cooling water system, water management systems, and the safety management systems. And also we have a few models for this lubrication. There's a supply and apply contracts in our agglomeration units. So these are all the services which are covered in the shop maintenance. So for the centralized maintenance, apart from the condition monitoring, we have this common equipments maintenance, the civil and steel building structures maintenance. We have the energy and environment management for the total plant. Also, the plant utilities and power distribution is in a centralized location. And the conveyor maintenance, we have almost around 450 kilometers length of conveyors. And also the central maintenance supports during major shutdowns and breakdowns. And the last one is the refractory maintenance management. So this is also in a common group. It's a centralized maintenance. Now, this is the maintenance methodology which is practiced in this location. So we have preventive maintenance, we have checklist and running inspection on a daily, weekly, monthly. We have condition-based monitoring. There are schedules and they are executed, and the compliance is reviewed if it needs any corrective or predictive actions. So they are being carried out. If there is again a feedback system that goes to the compliance. Of course, we have a breakdown maintenance, and that leads to a breakdown analysis or a root cause analysis. So any changes in the practice, like the preventive and corrective actions are taken, and then from there it follows the path of continual improvement. So we also have maintenance evaluation, so which is done on a monthly basis, where the availability and the MTTR and MTBF is monitored and projects are taken on it. There is a review and it leads to a continual improvement. So this is the methodology of maintenance. Now, these are the different equipments which are being maintained by the condition monitoring groups. So we have dynamic balancing, which is being done by this central maintenance group. So we also do ferrography for the gearbox oils, the hydraulic systems, wear debris analysis. So we have thermography, we have video scope. All these tools are being used in the condition monitoring systems, and the PQ analysis, which is done for the low speed rotating bearings. So this is one of the technique which is used for our VOF converter bearing condition analysis. So we have an in-house system, a lab, and we do a lot of sample collections, and we conduct all the analysis parts, and based on the reports, the corrective actions are being taken by the respective departments. So I have a few case studies from steel making, which I would be presenting now. So the first one is the predictive maintenance system in the converter. So VOF converter has got bearings which are of large size, and also one of the critical equipments in the VOF converter. So we have a few technical informations of the converter sizing. So these we have 180 ton heat size, 4 number of converters in SMS2, and 130 ton capacity 3 converters in SMS1. So these converters are being lubricated every fortnight, and the lubrication is basically a manual system. It's a pneumatic gun which is used, and we are using Skluber make grease, Stabutherm grease, and the bearings are SKF made. So their diameter is around 850 mm ID and 1120 mm OD. So I would like to just project these details. So we collect the grease sample from the bearings every monthly, and we do the wear debris analysis. So there is a trending of this data. Along with this data, we also measure the clearances in the bearing once in a year. So there is a recommendation for the bearing. Say suppose the manufacturing tolerances are somewhere around 600 microns, or say 0.6 millimeter. So we keep trending the clearance of the bearing. So this shows a slight increase in the clearance. So that's where the predictive model comes into picture, because we have a few points where the contamination levels have increased above the upper control limit. So this is a checkpoint for us where we further deliberate. And also we have the expansion of the bearing on the non-drive side, which is a free bearing. So we also do the monitoring of the expansion on the non-drive side. So with this 3 input data, we draw a conclusion, the condition of this bearing. So based on which a decision is taken for replacement of the bearing. So this is one of the predictive maintenance practices which are being done on the VOF converter bearings. So the next study is on the ladle turret. This is for the continuous caster. So we have 4 continuous casters in SMS2. We have 4 continuous casters in SMS1. And we have billet casters, 1 number in SMS2 and 2 numbers in SMS3. So this caster is also one of a very critical machine in which ladle turret is one of the most critical equipment which has got huge amount of load. There are 2 ladles. We are having steel of 180 ton on one side. So there's a big amount of mechanical loading coming onto this. And this ladle turret is rotating type. It rotates 360 degrees. So there is a slewing bearing which is here. So which is one of the vital component, and the monitoring of the health of this bearing is very important to have a continuous availability of the machine without any surprises. So this particular predictive maintenance for this particular component, I would like to show the details in the next slide. So here also we are using a Kluber make Stabutherm grease GH462, and there are the cycle time for greasing is 6 hours. There are 24 points, and the bearing is Rotor Iridium make. It's a diameter of 4,200 millimeter. So what we are doing is we have a fixed cycle of grease. Also, we have worked around on this the make and quality of the grease, and we do collection of the wear debris analysis from the bearing assembly, and these grease samples are analyzed. And apart from that, we also measure the angular misalignment in the bearings or the wear pattern on the bearing. So these are the different readings of the different casters which we have. So like you can see, like one of these casters, there is a steep rise which is being observed. So this is a point which triggers for us to take a decision. So this is what we are planning in the next year, to have a replacement of this bearing before a failure occurs. So this is the maintenance practice which we have in place for this critical equipment. So third and the important case study which I would be explaining is, in this continuous casters, the segments are one of the vital equipments through which the hot slab is taken out. So there are a lot of bearings installed in each segment. So we have casters in SMS2 which can cast up to a width of 2,200 millimeter. So they are SMS CMAG design, and the maximum speed is 1.6 meter per minute. So these are all the other technical details. The heat size of the caster is 180 ton. The annual production capacity is 1.35 million ton per annum. Now, I would like to just show the critical components which drive the reliability of the caster assembly. So we have spherical roller bearings installed, and there it's a split roller design. Like you can see, this is one roller and this another roller. So there's a split roller design. So we have a free bearings in the center and the fixed bearings on either side. So the technical details we have on here. The practice which we do is, whenever a segment comes out from the machine, we make a job cut for it, and we do the dismantling of the total machine. All the roll assemblies are taken out, all the bearings are removed. There is all the bearing assembly like the rotary joints, and all the components are disassembled. The critical components like the bearings, the bearing housings, all these are thoroughly cleaned. We have a cleaning practice, followed by an inspection for all micro cracks. We have a visual inspection. So where we inspect all the elements of the bearings, and we also measure the clearance of the bearing as per the recommendations of the OEM, and after which they go for assembly. So we have a roll assembly and a segment preparation shop. and finally then it goes to the installation. So this is the process of the maintenance practice for the segment repair. And a few data I would like to present. So currently we are having a 4,400 heats live for the segment, say 0.7 million ton throughput, after which the segment is taken out for the machine. And again, it goes to all those practices which I have just explained. So, and our next benchmark is to go up to 0.9 million. So wherein we are now, apart from the bearings, we are also working on the rolls. So the roll cladding material is also being tested and tried. So we are in the testing phase. So this is the one of the key maintenance practice in the steel melting shop. So these are the key performance indicators which I would like to present. This figures are for the total Vijayanagar works. So the lubrication consumption, we are somewhere around 233 kgs per ton of steel produced, and our lubrication cost is somewhere around 1.57% now of the total maintenance cost, and the overall lubrication effectiveness is at 96%. This is to keep the plant upkeep. So this is my presentation. Thank you. So any questions, I would be ready to ask.
So thank you, Mr. Murthy. Very good presentation. I would like to seek your permission to get it in article format so that we could publish it in our magazine in the next issue.
Sure.
My team will get in touch with you by Monday, so that if you could share this in text format, which we can publish along with your photograph in the next issue of our magazine, because it's a very informative presentation. So thank you so much, Mr. Murthy. Any questions for Mr. Murthy? Or Ankit, if you could see if there are any questions on the Q&A. There's one question Dr. Chanakya Tripathi has asked. What all parameters done online in hydraulic system at JSW?
So the contamination and the moisture. So these are the two measurements which we do on the hydraulic systems. So we have two types of practices. One thing is we collect a sample and it is tested offline in a lab. And in a few installations, we have an online machines, sample instruments which are mounted on the pipelines, which also give us the contamination levels, the NASH value of the oil.
Thank you so much, Mr. Murthy. So now we'll move on to Tata Steel.
Thank you.
Mr. G.R. Anil Verma. There is a question. Ankit, if you can just read it out for Mr. Murthy.
Yeah, so the question is, what lubricant is being used in caster segment bearings?
See, there's a new innovation which we have done along with Kluber, because we have enhanced the life of our segments almost twice. Earlier, they were somewhere around 1700 to 1800 heats. Now we reached 4000. So we worked with Kluber. It's a new grease which is developed in India. We partnered along with Kluber. So it's called Kluber Flex 98-201BH. So it's a new grease which is a semi-synthetic based, which we have worked and it's in use for the last 2 years, and we have very good results, because our problem was the width of the caster was more, 2200 mm. So there was a lot of heat radiation going on these grease pipelines and also onto the bearings. So we started using a normal EP2 grease long back, but we had a lot of issues, the bearing failures. Then we went to a high temperature applications, but still, okay, it had some improvement, but we were still looking for a better improvement. So the past 2 years, we had a new development along with Kluber, one of the manufacturers, supplier for us. So it's Kluber Flex 98-201BH. It's a new product which is used in JSW Vijayanagar for the first time for the past 2 years.
Thank you, Mr. Murthy. Thank you so much, Mr. Murthy. And once again, I would like to repeat that I want your presentation in article format for publication. So on Monday, I will get in touch with you with regard to this.
Sure,
so please stay connected for what Tata Steel has to say, because Tata Steel having its own legacy. I remember, I don't know, Mr. G.R. Singh would remember or not, Mr. C. Mishra was one person who was very active in the segment.
Yes,
Since
sir.
Sumpare,
He was my guru.
yeah, he was a guru for the entire, I think, maintenance industry all over.
Yes.
I happened to be with him on conferences, even in Singapore, where we were on the same panel together. So I gave a presentation, and Mr. Mishra, C. Mishra was also on that panel. So as I said, Tata Steel had a legacy of its own. So with that, I'll move on to what your presentation is likely to talk about. Since the floor is yours, let Tata Steel highlight what it has in store in terms of maintenance practices. Mr. Singh, over to you.
Yes, sir. So I will share my screen.
Yes.
So is my screen visible?
Not yet.
Okay, okay, okay. Yeah, is it
Yes.
visible? Yeah, okay.
Now it is. Now it is visible. Now it is absolutely visible.
Slide is not changing.
Please try and see if it change. It should change.
Just it's not changing, I think.
No, not yet. Ankit, can you help?
Yeah, so I also have a copy of your presentation, so maybe I can share the screen.
Yes, yes, I think that will be better. Yeah.
Okay.
Yeah, so you can stop sharing and Ankit will share it.
Okay.
Yeah, is the screen visible?
Yes,
Yes.
yes. Okay,
Okay.
okay. I think that is fine.
Yeah,
Okay,
just let me know when to change the slides.
Yeah, okay. So just go to next slide. So this slide gives overview of process flow at Tata Steel. So as all of you know, we have integrated steel plant now at Jamshedpur as well as Kalinganagar, and now TSBSL, Bhushan Steel Angul plant has also merged with Tata Steel. And we have iron making division with coke, sinter, and blast furnaces. And then we have steel making. So we have 3 LD shops, LD1, LD2, LD3. And then we have rolling mills. So we have both flat rolling as well as long product rolling. So we have hot strip mill, cold rolling mill, and then new bar mill, wire rod mill, and merchant mill. Next slide. So coming to our maintenance practices, so I will be talking about maintenance practices, and then again on lubrication practices. So what kind of maintenance practice we follow as far as lubrication and hydraulic systems are concerned. So as all of you know, if you consider maintenance as a process, so input is man, machine, spares and consumables, and output is reliability, availability, maintainability of the equipment. And now we talk about OEE, which is overall equipment effectiveness. So we also talk about process rate, which is also called speed factor, as well as quality rate. So overall equipment effectiveness is availability into process rate into quality rate. And for efficient conversion of input into output, the processes must be efficient and robust. So as all of you know, we have broadly 4 kind of maintenance practices, and now focus is more and more on predictive maintenance and proactive maintenance. Next slide. So as you all know, predictive and proactive maintenance. So predictive maintenance is also called condition-based maintenance, where maintenance is scheduled based on equipment health and not on a fixed time basis. So for predictive maintenance, we are using techniques like vibration analysis, then ultrasonic testing, then shock pulse metering, thermography, wear debris analysis, testing of lubricants, particle counting, etc. And as far as proactive maintenance is concerned, which is also called maintenance prevention. So you try to maintain the equipment in such a way that maintenance itself is minimized. So that can be done through design and practice of proper inspection system, whereas any abnormality is identified in the initial stage itself and corrective action is taken and failure can be prevented. Then we also do the root cause failure analysis, and at times you do the design modification, which is also have higher life from the equipment. Then things like contamination control. So especially in hydraulic systems, if you do a good contamination control, your failure will get reduced drastically. Then we also work on wear prevention, then reduction in friction, etc., which again gives higher life from the equipment. At the same time, we also have precise standard for installation of the equipment, so that once equipment is installed, it will not give any trouble. And at the same time, we also keep on doing performance audit of the equipment, and in case any failure happens, then root cause failure analysis is done and corrective actions are taken so that these failures do not repeat again. So with the help of predictive and proactive technologies together, we are able to bring in a breakthrough in maintenance, and continuously we are able to improve availability and reliability of the equipment. Next slide. So this is just to show that in any maintenance organizations, there are three groups, what we call LTD. So L is looking, which is basically inspection and condition monitoring group. T is thinking, which is the group who does the analysis and then re-engineering and bringing the best practices. And doer group is the basically which is doing job planning and execution. So in any conventional organization, you will find that doer group is the largest, and you have a very small L and T group, looking and thinking. But ideally, you should increase the size of looking and thinking group, so that automatically by doing this, your failures will reduce and you will need a smaller doer group. So though it still may be bigger than L and T, but it can be drastically reduced from the current size, and that is what we have done. So we have a dedicated inspection and condition monitoring group, which is part of the department called Maintenance Engineering Department. And at the same time, we have a thinkers group, which is a shared services technology group, which I am part of. So with the help of these two groups, and we have been able to considerably reduce failure, and which has also helped in reducing the doer group size. Next slide. So these are some of the benchmarks which I have taken from Plant Engineering magazine. So they say that when I was talking about various types of maintenance, so what it says that preventive maintenance, which includes fixed time interval, that means time-based maintenance as well as condition-based maintenance, should be around 70%, and 15% should be time-based, and 55% should be condition-based. And at the same time, proactive maintenance, it should be around 22%, and your reactive maintenance, which should be either 8 or lower than that, 8% or lower than that. So once you have more and more of condition-based maintenance or predictive maintenance and proactive maintenance, then automatically your failure will reduce. At the same time, it also says that your preventive maintenance compliance should be 95% and or more, and also your planned maintenance hours should be 90 to 95%. Next slide. So with this philosophy, now I will be talking about our lubrication management and how we have been able to adopt more and more predictive maintenance and proactive maintenance as far as our lubrication and hydraulic systems are concerned. So why lubrication management is so important? So as you can see, if you have a total distribution of equipment failures, so around 60% failures are because of lubrication related problems. So that is why lubrication management is so important. Next slide. So as you can see in this graph, though lubrication cost is very minimum, so it is hardly 3 to 5% of the total maintenance budget, but its impact on the maintenance cost is very high. So if your lubrication quality is good, then obviously your failures will reduce and maintenance cost will also come down. But if your lubrication quality is not good, then failure will increase and maintenance cost will also increase. So as far as lubrication is concerned, the 5 rights of lubrication are: right type of lubricant to be used, then right quality of the lubricant, right amount, right place at the right time. So these are the 5 R's which are very important for lubrication. Next slide. So this is one of the example from Nippon Steel, who were also our maintenance consultant at one point of time. So what lubrication excellence can achieve? So in one of the paper, they have shown that with improvement in lubrication systems, with the help of contamination control, then right lubricant selection, right lubrication method, and condition monitoring of lubricant as well as lubrication systems, they were able to reduce in one of the plants bearing failure from 400 per month to just 12. So this is the kind of breakthrough improvement which lubrication excellence can bring. Next slide. So again, need for high performance lubricants. So with 5R, we are also focusing on use of high performance lubricants so that equipment reliability can be improved. And for a steel plant, it is very important because steel plant equipment are subjected to continuous heavy loads associated with frequent shock loads, which is very prevalent in mills especially. Then now new equipment, so they operate at higher speeds. Also there is a hostile working environment like temperature, dust, fumes, water, etc. For example, in blast furnaces, spoke plant, you have very high temperature. Sinter plant, you have high dust. And obviously in hot strip mill, you have a lot of water with which your lubricant can get contaminated. Also, there is a load fluctuation in the process equipment due to operational requirement, and many times which allows equipment to work in boundary lubrication regime. So all these conditions call for use of high performance lubricants. Next slide. So coming to contamination control, which is again part of proactive maintenance. So this is the standard which we have set at Tata Steel. For example, hydraulic oil with servo valves. So we maintain NAS quality of 3, and hydraulic oil with proportional and conventional valves, we are maintaining NAS 5. And even for lubrication systems, we have started monitoring oil cleanliness, because many steel plants, they are only doing contamination control for hydraulic systems, but even for gear oil systems, we have started monitoring the oil clearance level, and up to 320 centistoke viscosity, we are maintaining NAS 7, and higher viscosity gear oil system 460 and above, we are maintaining NAS 8. And all the departments we monitor at monthly level, and whichever department process these values, then we immediately take corrective action and bring it back to green level. Next slide. As far as filtration is concerned, so here also we have put standards for filtration in hydraulic systems. So pressure line filter, we are using 5 micron, return line 10 micron, and recirculation filter 3 microns, because recirculation filter is the one which is most efficient, and because it works without any shock, etc. There is no pressure fluctuation. Also, even if hydraulic system is not working, but it will continuously keep on filtering the oil in the tank. So that is how recirculation filter is most effective. We are using also, we are using electrostatic cleaners to again polish the oil and maintain oil cleanness in NAS 3 level at servo systems. In hydraulic systems, you don't really need suction line filters. So we have taken out suction line filters, even if it is there, because it is not required as such. And many times even it can create problem in suction of the pump itself. So better not to use suction filters for hydraulic systems. Next slide. So coming to predictive maintenance part, so we are using lubricant analysis, and again lubricant analysis is used for both. One is monitoring the condition of the lubricant, so when to change the lubricant, and at the same time it also monitors the condition of the equipment. So based on, for example, ferrography report, it can predict that what kind of failure is happening in a gearbox or any equipment. At the same time, by seeing the shape of the particle, you can also find out what kind of wear is happening. Similarly, through FTIR or a spectroscopy, you can find out what elements are coming in the oil, and that can tell you that which component is getting worn out. Next slide. So these are the 3 techniques which we are using. So as I discussed, particle counting for, so we are checking both NAS class as well as ISO contamination class. At the same time, spectrometric analysis is to find out which what kind of element is coming in the particle, and ferrography. So all these 3 analysis we are doing. Next slide. So this is one example which I am showing, that we have bought a new particle counter which can even check high viscous oils. So this can check oil quality even for 680 viscosity. So conventional particle counters, they can only measure up to 320 oil only, but this particle counter can measure NAS class for even higher viscosity oils. Next slide. So this is again an example of Fourier transform infrared spectroscopy analysis of oil, which we are doing. So with the help of this, we are able to test new oil as well as used oil, or any mix-up of oil, or any degradation in the oil. So all kind of test is possible through this analysis. Next slide. Yeah, so this is one instrument which is on-site oil analyzer, and this we have used extensively for conveyor gearboxes. So with this instrument, with the help of just one drop of oil and 1 minute testing, you can find out parameters like total acid number, water ppm, and oxidation level of the gear oil. So we are using extensively, and we have been able to avoid many breakdowns with the help of this equipment. Next slide. So as we were discussing, so we are also going in a big way for IoT and digitalization, and even for hydraulic systems we have implemented. So in our thin slab caster, TSCR, we have implemented this digitalization and IoT in hydraulic systems, where various parameters are being monitored, and it is taken to the cloud, and then analysis is done on these parameters, and one index is found out, hydraulic system health index, based on which you can take a decision that what is to be done. So if there is a deviation, it will also tell you what to check. So whether to check the hydraulic cylinder or whether to check the pump, that kind of analysis it throws up. Next slide. And as I was discussing, so we have also set up one asset monitoring and diagnostic center at our maintenance engineering department, where data from all kind of equipment are coming, and then we are centrally monitoring those data, and if there is a deviation, then detailed analysis is done to find out the root cause. Next slide. We also monitor something which is called hydraulic fluid index, to know the actually consumption of oil. So hydraulic fluid index is total top up in a year divided by hydraulic tank capacity into 100%, and similarly lubrication fluid index is total top up in a year divided by lubrication tank capacity into 100%. Here benchmark figure is 18%, which is again from Nippon Steel. So for example, if you have a 10,000 liter tank, so in a year you should only use 1800 liter as a top up. So that is the kind of benchmark. So we again this also we monitor for each hydraulic and lubrication system. So though we have not reached to 18% level, but yes, many systems we are able to achieve what 40% or 50% level. Next slide. And with various initiatives, we have also been able to continuously reduce our hydraulic oil consumption as well as lube oil consumption and grease consumption. So this is the data for FY19, FY20 and FY21 till February. And as you can see, with the help of various initiatives, we have been able to continuously reduce the lubricant consumption. Next slide. I think this has got repeated, so we have discussed this. Next slide. Next slide. Yeah. So coming to another thing, what we have done as part of proactive maintenance, that we have standardized our lubricant based on application, which has given us good reliability of the equipment. For example, for caster application, we have standardized on polyurea grease. We have used lithium calcium grease with 460 base oil viscosity for hot strip mill, special lithium complex grease for cold rolling mill, then again lithium complex grease with 460 base oil viscosity for merchant mill, again coupling grease with high base oil viscosity for high speed coupling. So in many steel plants, you will find that even for couplings, people are using normal lithium EP2 grease, which is not correct, because in high speed couplings, there is a tendency for oil and thickener to get separated. And that is why you need to use specially made coupling greases for high speed couplings. Also for various application fire prone areas, we are using fire resistant grease, and also we have standardized on anti-micro pitting gear oil for typical gearboxes. Next slide. So here I have given you some case studies. So with the use of polyurea grease for caster and other high temperature areas, we have been able to reduce failures. For example, in casters, earlier we were using calcium sulfonate grease, which was having a lot of problems in choking of the lubrication system, etc. And also we were having many bearing failures. So now we have standardized on polyurea greases for caster application. And with this, we have been able to reduce bearing failure, as well as we have been able to reduce grease consumption. At the same time, polyurea grease is also used for other high temperature applications like hot strip mill and new bar mill, discharge roller table of reheating furnace, then roller table in hot strip mill, roughing mill area, and blast furnaces, high temperature area like bellows top. Next slide. Again, this is example from merchant mill, where we have used lithium complex grease NLGI1 with 460 base oil viscosity, and with the help of this, we have been able to reduce mill choke bearing failure to zero. At one point of time, around 2012, we had around 10 choke bearing failures in merchant mill. And from 2013 onward, we have started using this, and we have been able to achieve zero mill choke bearing failure. Again, why high base oil viscosity is important here, which I have highlighted, because as you see in roughing mills, so initial stands speeds are very less, and at lower speeds you need higher base oil viscosity to have a good film thickness. So what we have something called lambda value, which is specific film thickness, which is actual film thickness divided by surface roughness. And lambda value should be more than 2 for good lubrication. And we have calculated for each stand what is the base oil viscosity required, and we could find that initial stands, because speeds are lower, you need higher base oil viscosity, and because of this only we have gone for 460 base oil viscosity, because higher base oil viscosity will not create any problem in stands which are running at higher speed, but lower base oil viscosity will create problem as far as stands where speeds are low. So earlier in the grease, we were having base oil viscosity of around 220, which is there in general greases, but we have gone for higher base oil viscosity to have better lubrication. Next slide. Also, as I discussed, so we have used fire resistant grease at many places, and what fire resistant grease does, that initially if there is some fire which comes, so it creates a vapor, and then it creates a blanket around the grease which cuts off the air supply and which will stop further fire. So that is how this fire resistant grease works, and it prevents the spread of the fire. Next slide. So that's all from my side. If there are any questions, I will be happy to answer.
Thank you so much, Singh Saab. Thank you, Mr. GRP Singh, for an excellent presentation. Just like Mr. Murthy, I would like to have a written format, in a text format. आपका भी ये presentation अगर हम छापने का permission आपसे पाते हैं, तो we will publish this in the next issue. So I look forward.
Yes, I will do
I look
that.
forward to your presentation in not in PPT but in text format. If you could, because this is also a very interesting presentation with a lot of facts and figures, which I think our readers will also value in terms of the maintenance cost and the practices which have been adopted at Tata Steel for both Jamshedpur and Kalinganagar.
Okay.
So, if there are any questions for Mr. GRP Singh?
I have one question.
Yes,
yes, please.
Can you just share on this one shared services technology, Singhji?
Yeah, actually, earlier it was called Maintenance Expert Group, which has been renamed as Shared Services Technology Group. And shared services is basically our maintenance group is called shared services because our services are shared by all divisions, and it also includes power generation and utility, etc. And why one shared services? Because now Tata Steel has become multi-location. So this is a central group which now looks after all locations, starting from raw material to Kalinganagar to our Jamshedpur plant, as well as now Tata Steel BSL. So that is why it is called one shared services. So since we are looking after all locations, and our main some of the main job is root cause failure analysis. Then we prepare what we call standard maintenance practices. Then we are preparing Tata Steel standards, TSL standards, what we call. Then we are responsible for implementing new technology in maintenance. And we also run a lot of zero failure campaigns, like zero bearing failure campaign, zero gearbox failure campaign, zero conveyor failure, etc. So these are some of the activities what we are doing. And actually what I was saying, that it is a thinkers group which is supporting the maintenance organization of entire plant.
Okay, thank you.
So thank you, Singh Saab. Thank you so much, Mr. Singh.
Thank you, sir.
Again, my request is on Monday, I'll get in touch with you for publishing your presentation in the next issue.
Yes,
so which will keep on steel plant maintenance. So
yeah.
Both Mr. Murthy's presentation and your presentation, I really it was really a learning experience, and thank you so much from the core of my heart.
Thank you, sir.
So with that, things up, we'll move on to our last speaker. Our last speaker, we started with JSPL, then moved on to the manufacturers of grease manufacturers, then came back to the steel producers, and now we end up with another lubricant manufacturer, the Hinduja Group, which is represented by a company called Gulf Oil. And Mr. Umesh Chandra Dwivedi is our last speaker of the day, who is the general manager for global technology at Gulf Oil, Gulf Lubricants. So over to you, Mr. Dwivedi, to finish it off with the Hinduja Group. Please go ahead, Mr. Dwivedi.
Is my screen visible? Is my screen visible? That's all.
No, nothing is visible as of now. Only I can see you. And the Gulf logo. Okay, now it's there.
Now it's there?
Yeah, now you have to go to the full screen.
Great.
Yeah.
The screen is visible here. Am I audible?
Absolutely. Please
Great.
go ahead.
Yeah. Good evening to all of you. And thank you very much for giving us an opportunity to discuss on the subject of lubrication. And to this, before going into exact subject of lubrication, I want to give brief regarding Hinduja family and Gulf Oil history. It is the Gulf Oil is a brand and which is more than 120-year-old, and we have currently presence across the world except USA, Spain, and Portugal. We have worldwide operations, and India operations we will discuss little later in a couple of next slides. We are present into lubricants, marine, fuel retailing, car care, aviations. Like we have a versatile operations in field of lubrication, I'll say in terms of petroleum as a whole. And you can see our Gulf brand, how it has moved over a period of time. And now in our current Gulf logo, we have put 2 years also, where we always focus and listen what the market needs, what are the customer needs, and then we move across accordingly. Our core values is quality, endurance, and passion, and which we which is always on the top of the mind, and we strongly work along in the motorsports also. If you see the global positioning, we have a presence worldwide, and we have more than 20 blending plants worldwide. We have an excellent tie-up with OEM or leading global automotive OEMs and industrial OEMs, namely Volvo, Volkswagen, Mercedes. And industrial, we can name few: Alstom, ZF, Win Energy, Denison, Flender. We have worked very closely with them into different applications. And coming down on the India part as such, in India, we have 2 blending plants. One is at Silvassa, which is of 90,000 KL capacity, and other is at Chennai, which is 50,000 KL capacity. These 2 plants are ISO 9001, 2015, ISO 14001, and IATF certified plants. And we are into manufacturing of AdBlue also. And we manufacture complete variety of products, including automotive, industrial, mineral oil, synthetic, semi-synthetic. You name the thing, everything is being done. And our plant at Chennai is the latest plant, which is commissioned in 2018, and it has advanced automatic storage and retrieval system installed there. And in Chennai, we have our global R&D center also. Gulf Global R&D Center presently is based in Chennai, and which has a different all over the world requirement. Entire product innovations is being done and development work is being done here. We have a comprehensive product portfolio, more than 15 100 formulations, and more than 650 products. And we work very closely with OEMs. I think with this brief introduction about Gulf, I want to move straightway to the subject about steel plant and what is its maintenance. Steel plant, I also always love to talk about steel plant, as I have started my career after NIT Jamshedpur with a company called Usha Martin. Now it is a part of Tata Group. Major factors which affects the maintenance is very high temperatures, very high loads, atmosphere is very dusty. They are placed into remote locations. Now that is not the situation. Things have improved. But if you remember earlier days, still good amount, couple of plants are still located at remote places. Presence of moistures and water contaminations. These are the key factors which affect the maintenance. And major factor in consideration during maintenance, what we want from maintenance department, that is, we need equipment to produce more, equipment to be more reliable, operate 100%, reduce component spent, final product quality should be better. In short, I'll put that total cost of ownership of that machine should be the lowest, and follow HSSE guideline, health, safety, security, and environment. That should be always on the top of it, and which is getting more prominent when I visit and see present Indian steel industry. And I remember from my days of 1993 and 94, at the time, the atmosphere and the dust which was coming in the current scenario, it is much, much better. Industries have changed a lot. With this criticality and the factor, what we expect a lubricant to perform. Lubricant should perform into high temperature area. Lubricant should be able to withstand shock loads, high loads, should not get washed away because there's a good amount of water. Equipment protection, it should be pumpable. Product should reach to the point, and it should have high drain interval and maintain equipment temperature. Just to address all the things, I'm not going into detail-wise, equipment-wise, what product we have, but in such, we have a complete product line meeting a requirement of the steel industry, including from grease, lithium calcium grease, polyurea greases, and calcium sulfonate greases, greases with high viscosity, 220, 460 CST, 680 CST, even 1000 CST. That means we have a complete portfolio of greases, with the NLGI of 000 to NLGI 3. So that we, including moly greases, in the different technology of moly greases, even different percentage of presence of moly, meets all the critical applications requirement in the steel segment. Going down on the gear oil subject, our gear oil are called as Gulf Gear Tech. Gulf Gear Tech is we have vast portfolio. Even antimicrobeating products are available with us. We have entry-level Gulf Gear Tech HD, antimicrobeating product Gulf Gear Tech WT, and synthetic product Gulf Gear Tech SHG, and the polyglycol product Gulf Gear Tech PG, which I have not had. And out of this Gulf Gear Tech WT, SHD, they all have Flender Revision 16 approval in place. And product meets requirement of antimicrobeating. Wear rates are much minimal. The formulation is far superior. We have a hydraulic oil complete range with the Gulf Harmony series, and we have with Group 1, Group 2, and high viscosity index hydraulic oil. In the hydraulic oil, even energy efficient hydraulic oil products with the latest of Boss Extra approval of RD 90235 products are there in the portfolio. Coming down on the bearing and circulating oil, we have Gulf Security, which is for the Mongol applications, and Gulf Security NT for notice rod mill where we have tested the dynamic demulsibility results of our Gulf Security NT, and it is much lower what we have seen from the competent lab from global lab. That I think once we can interact with the individual customer, we can share all those details and move forward. We have a soluble cutting oil, which is called as Gulf Emulsil Na, and we have rust preventive, that is Gulf No Rust C2. Even high flash point rust preventives are available, and we are closely working with the steel plants of Tata and JSW, both the groups closely on the rust preventive also. I remember GRP Singh sir talking about 5 hours of golden rules of lubrication. Sir, I request to add one more, which is right people and the competent people doing the lubrication. That makes a lot of difference. Like we say, what is a golden rule? Like we should have a right product at the right place, at the right time, right amount, and right quantity. All things are important from a lubricant point of view. But the people who are lubricating the machine, we should have a right people doing the job, and we should educate them properly. We should have right competence of doing that. Otherwise, if we don't have right people doing the thing, all these 5 things will not be effective to get the full out what we want. Moving further, what we have to offer, Gulf, we have a complete lube products, including oil and grease, conventional and even specialty products are available from the single window. We have a field technical support placed across all the regions and near to the customer places. We have a complete condition monitoring services, oil analysis services, which is Gulf Care, easy product availability. Our 2 plants, which are located at Silvassa and Chennai, makes products availability easy. And we have an innovative offer, which is lubrication management program, and innovative cost-effective solution to reduce TCO, which we work with the customer very closely and talk to them and find out what are the key concerns and how we can reduce their present cost. What are the key worries they have in related to oil lubrication as a whole. And we don't take as a basic cost of lubricant. That is, we don't want to take that. We work as a total package and find out where are the loopholes and how best we can work jointly and reduce the cost. Even when we conduct a lot of training programs to their maintenance team to make them aware about lubrication and the lubricant selection. Because see, in the plant, a lot of times difficult situation comes. Sometimes we get stock is also not there. Then what mixing, what quantity, how we should move forward. We give a lot of education on that subject also. And we have a dedicated sales and technical service team presence across the country. Here, I want to discuss one innovative program which I talked about innovative offer, that is lubrication management program, which we are working in the industry, and which is present scenario, it is very important. This program we could able to successfully implement it in the iron making side. In the rolling side, we are yet to work upon, but certainly in coming years, we should be in a position to do that also. In the steel making area, we have been successfully able to do lubrication management program, which is like application-based solution, condition monitoring and analysis, and product safety and practices. What we do really, we take the job of lubrication in totality. We put our team there to do the job, including taking the sample, lubricating, doing the oil analysis report, telling you and improving the equipment, improving the process, and guiding you in totality, and working as we work along, we belong to you. That's all, I'll put that way. Team will be on the Gulf role, but they will work hands along with you, and we work very closely, which help to reduce wastage and overall lubrication KPI is achieved, which leads to lubricant excellence. It improves plant reliability, improved equipment reliability, and no HSSC issues, which is a good, excellent part of it, because the people who be there on the shop floor from our side, they are fully trained and educated. In short, if you say, it has a great impact on the total cost. In short, what we say, we are the lubrication expert. Let us do the job of lubrication. It's not that we don't want to become a supplier to you. We want to work on a model and supply and apply. That's all. So that let us do the even application job also, and then which will help to. You should focus on your core job of steel production related to lubrication. Leave it on us. As an overall, you have a good amount of saving by using our lubrication management program, products and services. We work and we do entire payment and work. It does not work upon that you pay on our supply. You pay to us on your ton of steel produced or ton of the output of that department, so that your lubrication expenses fixed. You need not worry about it. It works really a very positive model for the very friendly model for the plant as such. If you as an overall scope and services, we recommend the product. We study your each and every machine and what are the OEM recommendation. We work along that. We see Gulf products are recommended in that. We support you with all the documentation, and then we decide. We implement our condition monitoring program, continuous improvement projects we take with the help of our specialty product. We recommend you, we discuss and then implement those products and see the benefits and work along with you and the maintenance activities as a whole. And in this, you have a lot of benefit. You have a right product, timely service, optimized consumption, contamination control, dedicated manpower for it, condition monitoring. We have a complete, we follow the schedule, we upgrade the superior product, we go with the breather, grease, nipple, color. We do each and every job so that you do not worry about it. And then it's not been just done. We have to ensure that your machine is available. We do every monthly health check. We have a review. Every improvement project what we take, we discuss and see the implementation part and show you the results. And every monthly review is being done, seeing the lubrication quantity used and all. And every quarterly detailed report is submitted monthly, and even cost benefit analysis also we see every quarter and yearly. This we have implemented at JSW Jindal Vijayanagar and seen the benefit. And we secured LMB contract. We are doing this from 2017 in one or two shops, and then this year we got entry that PP1, PP2, PP3, SP3 for 21-22. And I'll really hats off to JSW. They are very positive and very aggressive on the subject, and they're always on the top of the lubrication across. That is the reason what we have seen in VSN Motin sir's presentation, excellent result, what they're doing. And there is a lot of thing into VSN Motin sir's basket, which I think over a period of 1 or 2 years, some more positive outcome will come, which I have been working with different department people, and they will be, their hats off, that's all. That is, I think, more I want to add. They have an excellent team, right people, and a good quality job on the lubrication. And along moving further in the LMP program, we have a Gulf Care, where we take operational expenses with the help of temperature profile, with the help of temperature gun. We do the complete profiling, visual inspection with the help of stroboscope, camera. We do the vibration analysis, centralized lubrication system inspection, cleaning. We do the oil sample testing, and from our lab, we provide you the results. During shutdown, we work along with you, complete inspection. We do the gear tooth profiling, oil sample, and subsequent testing and providing you the result. we work very closely with your OpenGear application team. I think this is the more details regarding LMP program, and for more details, I have shared the contact numbers of the right people, like BD Ojha is the General Manager, Industrial Service, Swaminathan for Health Technical Service, Tapas Chakravarti is a Senior Manager for Technical Service, and myself, General Manager, Global Technology. You can take a screenshot of that and feel free to write to us. Our mobile numbers will also I have mentioned. Feel free to call and we can discuss, and we can connect like as a consultant, as an advisor. We don't want to work as a loop supplier. What we have been said earlier also, we want to work along with you as a partner in your progress. Thank you. Thank you, sir.
Thank you so much, Mr. Dwivedi, for being to the point, for being, I would say, very precise and not taking too long for the last presentation at a time when everyone is so tired and hungry for the dinner.
Right.
So thanks for being short and to the point. At the same time, offering solutions which may seem very attractive for your customers, since you are not talking of payment terms on the quantity, but more on the total maintenance cost. So
yes,
that is a very positive approach in terms of business strategy, I would say. Maybe it's also an opportunity for your competition to look at offering such solutions to your customers in the steel industry. So with that, thank you, Mr. Dwivedi, once again. And of course, we will keep in touch, because this is, as I started off by saying, this is a subject very close to my heart. So I would like to continue to have series of both physical conferences and webinars. Physical conferences, of course, when COVID situation becomes a little more easier, and we are sure that we are not having the third and fourth wave at all. So we'll come back to physical conferences. Till such time, we'll have a series of webinars to go ahead. So with that, we come to the end of the session today. 5 hours, more than 5 hours, 5 hours, 10 minutes. So Mr. Dwivedi, if you stop sharing your screen, I would like to conclude today with the traditional vote of thanks. And Ankit, if you are there, can we get going with the conclusion today? And may I request Ankit to take over now for proposing a vote of thanks for today, and also summing up in brief in a few words about. Yeah, that's fine. Thank you, Mr. Dwivedi. Thank you. So any questions for Mr. Dwivedi? So Ankit, please go ahead with the conclusion and proposing a vote of thanks for our 36th webinar that we have done since the pandemic began. Over to you, Ankit. Ankit, are you there? Ankit? May I request Ankit to conclude? And before that, any final comment from Mr. Gadre, Mr. Murthy, Mr. Singh, Ajay Kumar ji, Mr. Biswas, any concluding remarks you would like to make? Any concluding remarks? Okay, so we assume that everyone is very hungry and satisfied with the day's proceedings. So Ankit, it is over to you to propose a vote of thanks. So Mr. Singh has said goodbye. He is taking leave. Thank you, Mr. Singh. And I will get in touch with you next week. So Ankit, it's over to you to propose a vote of thanks.
Yeah, so I will not delay any further. I will just say thank you to everyone who has joined the webinar today. Thank you to all the speakers. And my heartfelt gratitude goes out to our sponsors, our gold sponsor, Schaeffler, our silver sponsor, Indian Oil, our knowledge partner and supporting organization, NLGI India chapter. So thank you all for making this event possible. With that, I would like to conclude today's meeting.
So thank you so much. And next week, we have our conference on webinar on mining on the 19th. So those of you who are interested in mining, please stay tuned. And we will be, as usual, active both on Zoom as well as on YouTube channel. So you can join us anywhere. The YouTube channel, if you just search for Steel and Metallurgy, you will get our YouTube channel and you can join either through YouTube or through Zoom. Thank you and bye to everyone. Good night.
Thank you.
And have a nice weekend.
Yeah,
have a wonderful weekend. Thank you.
Yeah, thank you.
Thank you. Thank you, Murthy sir. Thank you so much.
Thank you.